हो केलाय बघा की आहे दिसतोय मी व्हिडिओ ऑन आहे की
Sir, good morning. Good morning, sir.
Good morning, sir.
गुड मॉर्निंग नमस्ते चिरके साहेब
Namaste, namaste.
जरा बसून बोलले का?
बसू.
Bote madam, please continue.
Success is not the key to happiness. Happiness is the key to success. If you love what you are doing, you will be successful. Honorable dignitaries, learned delegates, respected teachers, and your students, a very good morning to one and all. I take this privilege to warmly welcome all our delegates on the first day of International Conference on Advances in Science and Technology. To welcome is to show honor. To welcome is to establish integrity. I invite Dr. S.V. Patil, sir, the coordinator of today's international conference from Department of Chemistry, to deliver welcome speech.
Okay, thank you. Good morning, one and all present here for this 2 days online international conference in Advances in Science and Technology. I am Dr. S.V. Patil, coordinator of this conference and head Department of Chemistry, Rajarshi Chhatrapati Shahu College, Kolhapur. I welcome all dignitaries, all participants who have joined with us virtually for this conference. On the behalf of our college, I welcome to keynote speaker, Professor Dr. D.T. Shirke, Vice Chancellor, Shivaji University, Kolhapur, Professor Vilas M. Sadoke, former Vice Chancellor, Kaziranga University, Assam, and Principal of our college, Major Dr. R.S. Dubal, and Vice Principal Dr. V.V. Killedar. Welcome one and all. I welcome all eminent speakers and guests from all over the world from different walks of life. You have come here to share your knowledge and vast experience with the entire educational and industrial community present here. Our college always motivates all students and teachers to participate in such national and international research workshops, conferences, symposia to inculcate research values among them. Our student always participates in research competitions such as Avishkar, Rate Inspire, research competitions, and always secure higher rank in these competitions. Crux of this conference will be the use of digital technologies such as artificial intelligence, virtual reality, being increasingly adopted after the outbreak of COVID-19 pandemic. We must always hope to make an effort and ensure that inventions and discoveries in areas of science and technology are always used in the interest of the entire human race and to make the world a better place for you. Scientific knowledge teaches us to express our civic aspirations, our desire to connect with others and contribute to the world around us. We hope that these 2 days conference would help to expand our mental horizon. Thank you everyone for giving us your valuable time. Thank you one and all.
Thank you, sir. I request Dr. K.V. Gaikwad, sir, the convener of International Conference, to introduce about today's conference.
Thank you, ma'am. Good morning, one and all. I am Dr. Kishore Vinayak Gaikwad as an assistant professor in chemistry and the convener of today's international conference. I welcome all the participants on the behalf of Rayat Shikshan Samstha, Rajarshi Chhatrapati Shahu College, Kolhapur. This international conference on advances in science and technology aims to bring together a leading academic scientists, researchers, and research scholars to exchange their experiences and research results on the aspect of advances in science and technology. It also provides a premier interdisciplinary and multidisciplinary forum for researchers, industry practitioners, and educators to present and discuss the most recent innovations, trends, concerns, practical challenges, and the solutions adopted in the field of applied sciences. The conference will fulfill the opportunity for renewing old connections, making new contacts, and networking across higher education. The theme of this conference revolves around bringing science and technology research areas on an indivisible platform. This conference will draw collectively research fellowships from diverse fields in United Nations to share their research findings and latest ideas. The main intention of this conference is to integrate interdisciplinary inquiry to deliver the best applications. The international conference is a perfect platform for the students to express their innovative thoughts and unique research work at a global platform. It also discloses scopes to students to meet and interact with international speakers and scientists. The students can interact with session chairs related to working a new field of their research. To further redefine their innovations, students can consider the advice and technical suggestions of our chairs. The international conference has of 2 days. The first day, Dr. D.T. Shirke sir, the Honorable Vice Chancellor of Shivaji University, Kolhapur, who will guide us through a keynote address. For this session, the presidential speech will be delivered by Professor Vilas M. Saoke sir. He is a former Vice Chancellor of Kaziranga University, Assam. In the first session, we organize 3 lectures of an eminent scientist. The first one is of Dr. Deepak Shinde from National Physical Laboratory, London. The second one is of Dr. Rahul Zamdade. He is from Sharjah, UAE. Then the third one is from Dr. Pham Hong, who is from University of Science, Vietnam. The second session will be considered for oral and poster presentations of the participants. In the first session of the second day, we conduct 3 lectures of an eminent scientist. Again, the first one is of Dr. Yu Won from Malaysia. The second one is from Dr. Mahesh Suryavanshi from Australia. And the third one is from Dr. D.M. Sakte from the Central University, Tamil Nadu, India. For the valedictory function, we have a chief guest, Dr. P.P. Vadgaonkar, the emeritus scientist of National Chemical Laboratory, Pune. The president of this function is Dr. M.B. Sheikh sir, who is a member of Managing Council of Rayat Shikshan Samstha, Satara. With this brief information about the conference, I once again welcome all the participants and hand over the session to Anchor. Thank you.
Thank you, sir. I invite Professor Major R.S. Dubal sir, the principal of Rajarshi Chhatrapati Shahu College, Kolhapur, for the introduction of chief guest and president of today's function.
Good morning to one and all. A warm welcome to all the resource persons, faculty members, students, participants gathered online for 2 days international conference on advances in science and technology organized by my college. It is my great pleasure to introduce you about Rayat Shikshan Samstha and Rajarshi Chhatrapati Shahu College, Kolhapur. Rayat Shikshan Samstha, the mother institute of Rajarshi Chhatrapati Shahu College, Kolhapur, was established by late Padma Bhushan Dr. Karmavir Bhaurao Patil in the year 1919, which is one among the leading institutions in Asia. The Samstha celebrated its centenary year in 2019. The value of its contribution to education is enormously great. The motto of our institute is education through self-help. Rayat Shikshan Samstha runs 41 senior colleges, 2 B.Ed colleges, 1 engineering college, 1 law college. Beside that, 432 secondary schools, 25 pre-primary schools, 36 primary schools, 74 hostels, 8 ashram shalas, 6 industrial training institutes, 8 DED colleges, 158 junior colleges, 7 regional offices, and 59 other branches. A total of about 18,000 devoted staff working in 14 districts of Maharashtra and 1 district of Karnataka. Total students of about 4 lakh taking education in our Raj Shikshan Sanstha. Sanstha has been honored with various national and state level awards for its outstanding work in education. Now, brief introduction regarding my college. Rajarshi Chhatrapati Shahu College, Kolhapur was established in year 1962 and celebrated its Diamond Jubilee and re-accredited by NAC with A grade by CGPA 3.07 in 2017-18. Our college provides quality education in the field of arts, commerce, science, and computer education. The college is known for wrestling and kabaddi tradition and produce large number of sports persons at national and international level. College runs UG and PG programs, the self-financial, career-oriented courses, and skill-based courses. Majority of the faculty is engaged in research and completed number of minor and major research projects. The college bear well-equipped laboratories and swimming tank of Olympiad standard and produced national and international swimmers. With this brief introduction of Raj Shikshan Sanstha and my college, once again, I welcome you all for this online 2 days international conference on advances in science and technology organized by our college. Now, I will introduce about this inaugural functions speakers. First of all, I will introduce chairperson of this inaugural ceremony of this 2-day international conference, Honorable Professor Dr. V.M. Salokhe, former Vice Chancellor, Assam Kaziranga University, Jorhat, India. Professor Dr. Vilas M. Salokhe has 46 years of academic experience. He obtained BTech Agri-Engineering degree with gold medal from Mahatma Phule Krishi Vidyapit, Rahuri, India in 1974. Master of Engineering with distinction from then Sukhadia University, Udaipur, India in 1983. And Doctor of Engineering from Asian Institute of Technology, Bangkok, Thailand in 1986. He started his academic career as an assistant professor at the Mahatma Phule Agricultural University since 1974. He joined AIT as a visiting faculty in the year 1987 and professor in July 1996. Till December 2009, he was professor as well as director of Unified Program at AIT. Since September 2010, he joined as a founding Vice Chancellor of Assam Kaziranga University, Jorhat, India, and finished his term by July 2015. Since 14 December 2015 till March 2017, he worked as a Director Academics at D.Y. Patil Technical Campus, MB Pune. Dr. Salokhe's research interests include human factor engineering, soil mechanics, farm machinery development, greenhouse technology, and agribusiness management. Dr. Salokhe handled 36 research projects funded by various national and international donors. The total cost of research projects fund obtained from local and international agencies is worth over 120 millions. Dr. Salokhe has published his research work extensively through more than 320 papers published in international journals, conference, proceedings, and presented at various meetings. He has co-authored 1 book and edited 18 proceedings. He has supervised 24 doctoral students and 97 master students. He has worked on various institute committees. He organized 22 conferences, workshops, seminars, and participants in 100 different international conferences throughout the world. Professor Salke also worked on editorial board of many reputed international journals. Till December 2021, he was the editor-in-chief of International Agriculture Engineering Journal published by Beijing, China, and president of Asian Association for Agricultural Engineering. He is a fellow of the International Commission of Agricultural Engineering and International Society for Terrain Vehicle System, USA. He is also life member of American Society of Agricultural Engineers. He is a member of Board of Executive of International Society of Bionomics Engineering, China. So again, I welcome Honorable Professor Vilak Salke Sahib. Then I will introduce today's inaugural functions. Speaker, Honorable Vice Chancellor Shirke Sahib, Professor D.T. Shirke Sahib, the Vice Chancellor of Shivaji University, Kolhapur, completed graduation from Vivekananda College, Kolhapur in 1985. Post-graduation from Department of Statistics, Shivaji University, Kolhapur in 1987. He joined the Department of Statistics as a CSR Research Fellow in 1987, where subsequently he joined the Department of Statistics in 1990 and headed the Department of Statistics from 2005 to 2015. He has around 30 years of teaching and 33 years of research experience. He has extensively published and has almost 70 plus national and international publication on his credit. He has completed 5 research projects funded by various national funding agencies. 14 students have successfully completed their PhD under his able guidance. He has attended over 50 national and international conferences and has organized 6. As an outstanding researcher, he has delivered invited talks, speeches in many conferences, workshops, symposia, refresher and orientation courses, both within and outside the India. He has traveled extensively in India as well as abroad, visited USA, Switzerland, Portugal, Germany, Thailand, Singapore, and Malaysia for academic purpose. As a researcher of international repute, he has varied research collaboration both within India and outside the country. Like his academic concern, his administrative experience is also varied, and it includes his position as officiating registrar of Shivaji University, Kolhapur for a period of 2 years, as a institutional coordinator of RUSA, coordinator of University Industry Interaction Cell, coordinator of UGC SAP, coordinator of innovative programs, and so on. He has also worked on various bodies of university, including the Senate, Management Council, Academic Council, Finance and Account Committee, Budget Committee, IQAC. Recently, he worked as a Pro-Vice Chancellor of Shivaji University for 3 years. Considering his substantial academic and administrative contribution, he was awarded as a best teacher by Shivaji University, Kolhapur in 2011. He has consistently shown his talent for fetching various awards and fellowship. As a student, he is the recipient of state government scholarship, national merit scholarship, and he was university ranker for UG and PG classes in sciences. In a recognition of his academic excellence, he was awarded with Jawaharlal Nehru Memorial Fund Award twice and Summer Research Fellow of Academy of Indian Sciences, India. He is an elected member of International Statistical Institute, Netherlands, and is also the member of many professional organizations in statistics. With this brief introduction, I will request today's chief guest, Honorable Shirke Sahib, to inaugurate this session. Thank you, one and all.
Thank you, sir. Now I request to Professor Dr. D.T. Shirke, the Vice Chancellor of Shivaji University, Kolhapur, to deliver keynote address.
Good morning to you all. The president of inaugural function of 2 days online international conference on advances in science and technology, the former Vice Chancellor of Kaziranga University, Jorhat, Assam, Professor V.M. Salunke, Principal of Rajarshi Chhatrapati Shahu College, Principal R.S. Dubal, Vice Principal Dr. V.V. Killedar, organizer of this conference, Dr. K.V. Gaikwad, in charge of science faculty, Dr. S.V. Patil, all the faculty members of Rajarshi Chhatrapati Shahu College, research scholars, and the participants of this particular international conference. First of all, I congratulate the principal and his team for organizing international conference on advances in science and technology. As rightly said by coordinator as well as convener, you want to bring researchers, faculty members on a common platform to discuss discoveries, inventions, research in various domains of science and technology. And at the beginning of launching and implementing our nation's national education policy, and this is the right way of organizing conference. We all are suffering and have already suffered a lot since last 2 years. And online conferences, organization of such conference is now becoming one of the important events in not only in universities, but in the affiliated colleges as well. I personally feel now we should not all the while relate the word online with COVID. COVID-19 forced us to do this particular thing. That doesn't mean that we should not ever organize the things in online manner. Online academic events and its organization has itself a lot of advantages. For example, today, the president is sitting in his residence. I am sitting in my office. Principal and most of your faculty members are in their college and offices. The invited speakers are outside the country, and many of the domestic or national speakers and participants, they are in their respective states and maybe in the institutions. So bringing all of them together right at 10 o'clock and starting academic discussion is really a Herculean task. So sitting over there and participating in this academic is possible only because of this online mode of organizing this conference. So let us take the advantages of the technology and go ahead. Of course, this itself is an invention, this itself is a discovery. Before 2 years, organizing such kind of thing, I think we had never thought of. But now we changed, and maybe within a notice of 1 hour or 2 hours, we can immediately organize a meeting of anyone. Of course, provided the person to be participating in the meeting has got platform and technology and connectivity. Of course, those things are now a part of life, and everyone has got the technology at their hand, and they are definitely using for the best purpose for these academic events. Coming to the topics that are being listed in the program, I'm really highly impressed to know that the topics of variety of domains and varied interest will be discussed in these 2 days. If you try to put all such topics under a single umbrella, of course, science and technology itself forms an umbrella to discuss all those things. But beyond that, if you really think about what exactly is being discussed, what is the major area under which the topics are being discussed, I would say that these topics can be considered to be topics under sustainable development. I think we all are talking about sustainable development, and our nation and the central government, state government, local bodies, they are striving and they are trying to implement various activities to reach the 17 sustainable goals. And to my great surprise, some of the topics, for example, particularly the greenhouse gas emission from paddy fields. The researcher is from Climate Change Center, and he would be talking on greenhouse gas emission from paddy fields. Can you imagine that we are talking about a climate change? We are talking about artificial intelligence. Now, already boundaries are in fact removed from one subject to the other subject. Another topic is artificial intelligence for accurate species identification. I think the title of the talk itself says that you are using a technology from computer science in botany, something like that. So these kind of things are happening, and that is a good sign. Why this is a good sign? Because we are talking about the national education policy, wherein we advocate, and we are, in fact, after implementing the where the multi-faculty, multidisciplinary education and research will be given a due importance. And this can be regarded as one of the steps towards this. So in this particular 2 days conference, the topics which are of varied interest but falling under a common, I think, theme will be discussed at the great extent. And another thing what organizers, in fact, shared, and which I like the most, is that it is not only a 2 days conference will be discussed and there will be exchanges and so on and so forth. You can have some planning of taking the things further. You can adopt, you can think of even enhancing, making it more efficient and so on and so forth by adding your skills, by putting some more efforts and so on and so forth. Beyond that, I think you can open some avenues to collaborate with the researchers within country as well as outside country. And I think the greatest advantage of organizing such conferences is knowing each other academically. So what others are doing and what I am doing, what we are doing, should be made known to each and every person who is involved in this particular conference. For example, species identification person from botany, all the botanists should seriously think about this particular approach, because I think I'm not expert in botany, but I think this field is called as a taxonomy. So in this particular field, many people, and Shivaji University is working, I think many people in the Shivaji University are working in this particular area. So bringing AI into botany, inviting concept of AI into botany can be made very general also. This can, in fact, cross the boundary of botany and can enter into zoology also. It can go to chemistry also. And you can just think about what are different areas wherein this AI can be used. It is known, and you must have read, that applications of artificial intelligence, they are not limited to only specific sector. People are using AI in health. People are using AI in industries. People are using AI in IT sector itself, because all these, you can say, social media platform, very rigorously and effectively and aggressively, the use of AI is being done. So such conferences will bring such ideas made known to each and everyone. Otherwise, once the word AI is spelled out, we were thinking that it is only a computer science baby. So we would not touch to that. Even our mathematics person may say that, I don't know what is this AI. But a strong mathematical background is there while developing the things within the AI. So AI is one of such things. It could be Internet of Things. It could be a machine learning and so on and so forth. Such, I think, techniques and inventions should be brought to the notice of all people. I was just looking at the program, and I felt, I'm just trying to share with you. What is that? See, while doing all these things, we are talking about science and technology, but I think the conference is much loaded with science only. You hardly find a person from technology except today's president. Today's president happens to be a person from agricultural engineering. You can see that what kind of engineering, the agricultural engineering. Engineering is there, but the domain of agriculture. But the rest of the speakers are coming, most of them are coming from the pure science background. Of course, again, a national education policy has a thrust of bringing these kind of things together. So what happens when we organize a conference in science college, engineering college may think that this is nothing to do with us, so they don't bother. And when the conference is being organized by engineering colleges, we think that it is some kind of technology and engineering. Science people don't have to do anything. And that is where we go wrong. And that is where we have to correct. And we have to come together. So why not some technologists also participate in such conferences and share their knowledge, their invention, their discoveries with the science people. And no discovery can take place in a single domain. You can't think about, you just think about a mobile as a, in fact, I should say that it is the greatest invention is a 20th and 21st century. If you try to look at that device, you will come to know that how many disciplines are involved in those. Right from electronics, you have got a physics, you have got a chemistry, you have got a mathematics and whatnot. You have almost everything over there. Of course, humanities is also there. But the only thing is that you have to at least see in what way you look at that particular. It's I think how does it look? Is the arts is also there. So many things are there, and we cannot develop anything in a single domain. We will have to take help of the others, and we are realizing very late, but it is not too late also. So now it is high time to come together and exchange the ideas, exchange the expertise. What expertise I have got, I should make known. I should at least tell others that these are the things in which I am expert. And we, at the same time, we should appreciate the expertise from the other fellow also. So if you do that kind of thing, I think going ahead in multidisciplinary research and science and technology research.
Users? Sir, you are muted, sir. Hello? Unmute yourself. Activity by decreasing the sir, unmute yourself, sir.
I think the controller has muted me, right?
It's okay, sir. Okay.
Okay.
It's okay, sir.
Yeah. So 3 types of institutes will be there. The first is research intensive universities. The other one is teaching intensive universities, and the colleges will be degree awarding autonomous colleges. So when we talk about these 3 categories of institutions, now the journey from a college will go to a degree awarding institutions. That institution can be a autonomous college, or it can be university as well. So the sky is open. Whether you want to fly as a university or you want to fly as an institution, it all depends on you. And then all such disciplines have to come under that particular roof of that institution. That is not only a science or arts or commerce. You also invite the kind of pharmacy, kind of engineering and technology, and so on and so forth. I think we all have to bother about the provisions of NEP and how to bother about implementing in true spirit all those things if you really want to contribute to the higher educations and research as well. I think this conference will at least meet some of the expectation from national education policy at one side and the higher education within our country at the other side, and bring the people from different areas on a common platform, and will open at least opportunities to have a collaborative work. It could be a teaching also, collaborative teaching also most welcome, collaborative research also, collaborative extension work also, and so on and so forth. Before I close, I just would like to pay my tributes and respect to Karmavir Bhaurao Patil, and I just would like to spell out those 2 lines of Rayat Geet. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे, वटवृक्षाच्या विशालतेचा मोह नभाला पडतो आहे. I think it's a great song written by Vittal Wagh, And every word in the song will give you a different opening to think about higher education, not only for development of an individual, but the development of the society and development of nation as well. My best wishes to all of you for these academic events for today's and tomorrow's, and many such events in the future as well. Thank you so much, and namaskar.
Thank you very much, sir. Your thought-provoking address set a perfect platform for our speakers to deliver their presentation. Now, I request Professor Vilas Salkhe, sir, the former Vice Chancellor from Kaziranga University, Assam, India, to deliver presidential address.
Sir, unmute kara. Please unmute yourself.
Can you hear me? Hello?
Yes, sir. Yes, sir.
Can you hear me now?
Yes, sir. Proceed.
Okay. Chief guest of today's function, Honorable Vice Chancellor of Shivaji University, Dr. D.T. Shirke, sir. The Principal of Rajasri Chhatrapati Shahu College, and the Chairman of this conference is Professor Major R.S. Dubal, sir. The Vice Chairman, Dr. Vilas Killedar, sir. The convener of this conference, Dr. K.V. Gaikwad. Distinguished participants within and outside India, faculty, staff, students of the college, ladies and gentlemen, very good morning to all of you. It is indeed an honor and privilege for me to attend and be a president of this important conference. The theme of the conference is Advances in Science and Technology. Looking back, we can imagine the life of during the Stone Age till evolutions into current era. These unimaginable changes over the years were possible only because of humans have always been very inquisitive and innovative. We have passed through various stages of experimenting many developments, amassing huge knowledge about millions of things over the hundreds of years, and we continue to utilize this for the advancement of mankind. I remember the comments by famous British journalist, historian, broadcaster, and philosopher, Professor A.J.P. Taylor, a fellow of British Academy, who has credited all advances to humans' distinct attitude of non-conformity. What is non-conformity? Which means that we don't accept the things easily. We always question why, how it happens, and why not. So that is our nature. So what he says conformity may give you a quiet life. It may bring you a university chair, but all changes in the history, all advances come from non-conformity. If there had been no troublemakers, no dissenters, we should be living in the caves, unquote. Currently, we are all living in scientific era that is modernized. Advancements in science and technology have made our lives more comfortable and healthier. This change in our lives has been possible due to miracles of science and technology. Science and technology are the backbones of the new inventions and development. Science is defined as a knowledge, fact, or information. When this knowledge is put into practicality, it turns into to be a technology or new innovation. Science enhances our curiosity after observation and technology is a result of working on this idea or curiosity by creativity. We cannot imagine our life without science and technology, as it involved in everything we do in day-to-day life. Now, how have science and technology made our life convenient? We can answer this question by giving few examples. Science and technology has given rise to a number of machinery and tools in different fields. I think Dr. D.T. Sirkesar already covered many of those areas. These tools and machinery have made our work easier than doing it manually. The use of these tools and machinery has helped in reducing the cost, time, effort, and energy required in doing different works. For example, the invention of computers and the internet is a blessing for the mankind through which we can handle numerous tasks efficiently. Today, the use of computers has become a must for the humans. Science and technology have brought specific changes in the education sector. The availability of online books, online classes, e-library has greatly helped the students and teachers in knowledge disseminations and acquire. At present, any type of information can be obtained with just one click on computer. Especially during the current pandemic, enabling students online classes as well as work from home for the workers has further proved inevitable importance of technology in our lives. And today's online conference is also another example. Science and technology have boosted research and development in different fields. The results of these researches give rise to new discoveries and innovations. It also helps in increasing the economy of the nation. The technological advancements in different sectors have led to the progress and development of different nations in the world. Science and technology are the ultimate need of an hour that changes the overall perspective of the human towards life. Over the centuries, there have been numerous inventions in the field of science and technology that help us in modernizing our lives. Right from connecting with the people to using digital products, everything involves science and technology. In other words, it has made our life easy and simple. There is a modern equipment explored by tech experts to find something new for the future. Science and technology has no doubt the greatest blessing of God to the humans. It must be used wisely so that there is no chance of any problem with the existence of other species on this earth. Gentlemen, globally, last 2 years, we are facing unprecedented situation caused by the COVID pandemic, and it's not completely over yet. However, life has to go on, and this has been shown by the organizers as well as the participation of various scientists and engineers in this conference. I wish to congratulate the organizer, Principal Professor R.S. Dubal and his team for hosting this online international conference, which has participation of scientists and engineers from within and outside India. It is a wonderful opportunity for the participants to share their findings and also to learn from each other the ways science and technology is progressing. Finally, my personal thanks to the organizers for inviting me as the president of this conference. Thank you, and wish you all fruitful deliberations over the next 2 days. Good luck. Jai Hind.
Thank you, sir, for your work. To deliver a vote of thanks to all the dignitaries and the guests, let me invite Dr. V.V. Killedar, sir, the Vice Principal of Rajarshi Chhatrapati Shahu College, Kolhapur.
Hello, Shaileja.
One minute. Okay. Hello. Good morning to one and all. Chief guest of today's function, Honorable Professor Dr. D.T. Shirke, Saib, Vice Chancellor, Shivaji University, Kolhapur. President of the function, Honorable Professor V.M. Salunke Saib, former Vice Chancellor, Kaziranga University, Assam. Principal of my college, Professor Major R.S. Dubal, Coordinator, Dr. S.V. Patil, Convener, Dr. Kishore Gaikwad, and our most valued invited guests, ladies and gentlemen. It is my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of Rajarshi Chhatrapati Shahu College, Kolhapur, extend a very hearty vote of thanks to Professor Dr. D.T. Shirke Saib, Vice Chancellor, Shivaji University, Kolhapur, for accepting our invitation and inaugurating the education conference and delivering a keynote address in a simple and lucid manner. Sir, we all are inspired by your great words. We are also grateful to respected Honorable Professor V.M. Salunke Saib, former Vice Chancellor, Kaziranga University, Assam, for presiding over the function and giving his valuable guidance to all of us. I may like to express our sincere thanks to in-charge principal of the college, Professor Major R.S. Dubal, for inspiriting us and providing all sort of help during the organization of this international conference. We are also grateful to the chairman, secretary, joint secretary, managing council members, and general body members of Rayat Shikshan Sanstha Satara for their valuable guidance and support. I also express our sincere thanks to all the dignitaries, resource person for gracing the function with their presence. I also wish to express my gratitude to student and teacher participants from all over the globe for their active participation in this session. I also extend my thanks to Dr. S.V. Patil, coordinator, Dr. Kishore Gaikwad, convener of this international conference, and Dr. S.P. Pawar, ICAST coordinator, for their enormous cooperation in organizing this event. Once again, I like to express sincere thanks to the College Development Committee, Conference Organizing Committee members, teaching and non-teaching staff of the college for their timely help for making this event a grand success. Thank you very much. Now I hand over to Prachi Madam. Thank you.
Thank you, sir, for your words. I invite Dr. S.P. Pawar, sir, the Assistant Professor from Department of Chemistry, to introduce today's chairperson.
Prachi, very shortly, the resource person of this session will join. Very shortly, just I called him. As per the schedule, this session will be started at 11 o'clock.
हा म्हणजे तेच मी पण विचारतो तर पाहुणे जाऊ शकतो.
सुरू झालेलं आहे. सुरू करू?
ऐकू.
Now I welcome Deepak Shinde sir. Hello. Unmute sir. Please unmute yourself. Deepak Shinde sir.
Hello. Good morning.
Okay. Now hand over to Samadhan Pawar sir.
Good morning, one and all. Myself, Dr. Samadhan Pawar, Assistant Professor in Chemistry, R.C. Shaw College, Kolhapur. I welcome resource person of this session, my friend, Dr. Deepak Shinde, Chairperson, Professor Sheshnath Bhosle, and all the participants and delegates. Dear friends, it's my immense pleasure to introduce Professor Sheshnath Bhosle, who is going to chair this session. Professor Bhosle currently working as a UGC professor at Goa University, Goa. He did his BSc from Dr. Babasaheb Ambedkar University, Aurangabad, India. Then he did his master degree from Swami Ramanand Tirth Marathwada University, India. Then he did his doctoral degree from Ferry University, Berlin, Germany. He has completed graduate certificate of higher education at Monash University, Austria. He has worked for several different organizations in various countries. He started his research career from National Chemical Laboratory, Pune in 1999. Then he did his postdoctoral. He also did his postdoctoral fellow at Ferry University, Berlin, Germany. Then in 2005, he did his second postdoc in University of Geneva, Switzerland. Then in 2006, he worked on position of ARC ADP fellow, Monash University, Clayton, Victoria, Austria. Then in 2009, he joined as a lecturer in Monash University, Clayton, Victoria, Australia. In 2011, he also worked as a ARC Future Fellow in RMIT University, Melbourne, Australia. Then in 2016, he has worked as a Senior Research Fellow at same university. Then in 2018, he joined as a UGC professor in Goa University, Goa. His area of research interest is nanomaterials, supramolecular chemistry, sensors, bioorganic chemistry, artificial photochemistry or photosynthesis, and organic solar cells. He has been working on editorial board of several journals. He has established strong collaboration with many researchers from Germany, Japan, Canada, US, Switzerland, Italy, and India. In total, he has published more than 250 research articles in various highly reputed journals like Science, Chemical Review, Chemical Society Review, Nature, JACS, Angewandte Chemie, and Organic Letters. Due to high quality of his research, it has been highlighted on the cover page of 15 prestigious journals. His citation index is more than 7,000. His H index is 38, I10 index is 151. Moreover, he has published 1 book and 10 book chapters in various publishing societies. He has been awarded by several awards and grants like Fellow of Royal Society of Chemistry, Member of Royal Australian Chemical Institute of Chemistry, Australian Future Fellow, Maxwell Eagle Endowment Award for Cancer Research, RMIT Faculty of Science Overseas Travel Grants for 3 times. Then he also got travel grant from Monash Faculty of Science Overseas for 2 times. Then Australian Postdoctoral Fellow in 2008. In 2008, he also won the Young Scientist Award in International Conference on Drug Discovery and Nanotechnology held at Nanded University, India. He received Roche Foundation Postdoctoral Fellow to work with Professor Stephen Mattheil at University of Geneva, Switzerland. There are so many more awards and recognitions he got. Due to time constraint, I here mention very few. He delivered more than 100 invited talks in various conferences, workshops, and symposiums. Actually, when we see the biodata of Professor Sheshnath Bhosle. His biodata having 51 pages. It is quite difficult to introduce him. Therefore, here I introduce him very shortly. I now request Professor Bhosle to take the charge as a chairperson of this session. Over to you, sir.
Samadhan, I'm audible.
Yeah, you're audible,
Okay.
sir.
Thank you, Samadhan Pawar, introducing me. 51 pages biodata, you cannot read it because this is conference. I must take over this charge because we need to listen to the Dr. Deepak, who is a really young scientist, you can call it, and he is a product of our university. That's why I take my privilege to introduce the Dr. Deepak Shinde. He might feeling the cold. He has the jacket on him. He did he's a master from our university, Shivaji University itself, in analytical chemistry, and BSc from Solapur. I don't know how it matches. Solapur is different and Kolhapur is different, but somehow he come to Kolhapur from Solapur. Then he did a PhD from Shinde. Please correct me if I'm wrong. University, and it is one of the famous university in South Korea. It's introducing him is just like we're saying someone is good, someone is good, someone is good. It's not like that, because he has published really good research articles. Like if you take one example, advanced functional material impact factor, Shinde, it's maybe 12 or 15.
Yes, I guess so.
Yeah. Okay. And he has also many publications, like you can see that Journal of Material Chemistry and so on. We are looking forward to listen to you. And you are Shinde sir, Dr. Deepak Shinde sir is working in the material and electrochemistry. And this is very important field, because nowadays what happen now, if you want to detect the any material like metals, toxic metals from the water or some sources, it's very difficult to carry on the UV fluorescence and so on. But if you have the electrochemistry small equipment, you can detect those particular hazardous metals and so on. And we are looking forward to listen to you. And one more thing I just want to mention, he had published 42 articles. His H index is 21. With 42 article having the H index 21 and citation 1253, he's bigger than me. I don't want to say anything more than that. But he has also two patents, yeah? And he has a couple of he secured a couple of research grant from European Research Council and so on. This is a really privilege, having one person going from our Shivaji University, working in who did a master in analytical chemistry, and then moved towards the inorganic and material chemistry, did PhD, and then he not only stay there, he moved towards the electrochemistry and using the material for the electrochemistry. It's a very diverse field. It's for audience. There are many young students there. I just want to say that, like, at the end we will have some discussion, and I ask young student, please ask the question to the Shinde sir, because this is the way you can learn. Otherwise, you just sitting or just log in and getting certificate, paying 200 rupees is not a big deal. Gaikwad sir arrange per year to like international or national symposiums, conferences, you join and get certificate. It's not a way. Yeah, you should become the Dr. Deepak Shinde in future. That's what I want to say. I will hand over to the Deepak Shinde sir. I will come back to the Zoom meeting. I'm on my hometown, Deepak. मी उदगीर मध्ये आहे सध्या. मोबाईल वरून मी बोलतोय. Okay. Okay. Please go ahead. Please not only give only like a hypothesis or give them like a high level English. Sometimes you should bit speak in Marathi as well. Why this is important so on. Yeah. तुला मराठी ते मला कळलं, त्यामुळे थोडं मराठीमध्ये वगैरे असं एक दोन पॉइंट सांगत जा. Okay. Thank you very much. I must thanks Gaikwad sir as well. because he's one of the best friend. I never met him so far, but we are a Facebook friend. He's one of the inspiration for this college, because whatever he does, he put on the Facebook and people use that like a, and he does a lot of practicals and show the students and he put on Facebook. I love that. And then you are the one of the fellow from this Shivaji University. I really appreciate how you progress, and we will have some discussion later on. Okay. I will hand over to Dr. Deepak sir. Is that fine? Power sir?
Yeah, it's fine, sir.
Okay.
Yes, sir. Thank you, sir.
Thank you, Deepak. Please go ahead. I will mute. I will mute, and I will also stop my video. Okay. Thank you. Okay. Okay, Deepak. Go ahead, please.
Good morning, everyone. It's a bit early in London here, 5:30 a.m. It's a great pleasure to be delivering talk. Dr. Samadhan, a very close friend of mine, classmate, and really like a brother. Really thankful to him and to his college, Shahu College, and to Shivaji University for inviting me. It's a great pleasure to be delivering talk on a topic that that is of interest, and that is of interest not only to me, but I think whole world at the moment, considering the ongoing war between Ukraine and Russia, the issue of fuel security comes up often. So I'm gonna talk more about that topic, alternative fuels. So let me, sorry, I forget one thing, to thank Professor Bhosle for a nice introduction. I'm not as big as he told us to be. Just a small scientist trying to learn things really. So let me start my presentation. Let me share my screen first. It's been long time that I haven't used Zoom, so let me figure it out how to.
Deepak, just click that share button. I think the
participant screen sharing, maybe host needs to.
Yeah. Power sir, Gaikwad sir, please allow him to share the screen.
Yes, sir.
Yes, sir. Yes, sir. Just check, sir.
1 minute.
Okay.
Okay. Yeah, I think it's working now. Can you see my screen?
Yeah.
Yes, sir. Your screen is visible, sir. Please continue.
But you can make it a full screen or whatever you want now.
Yes. Yes, sir. It's visible, sir. Please go ahead.
Okay. Okay. Thank you. So I will continue. The topic of my talk is advanced electrocatalysts and measurement techniques for green hydrogen production. So I'll really be telling two stories to make it less boring for the audience, and not really going into technical details of every project that I did. So whatever work I'm gonna show here was done at my previous workplace, which is Istituto Italiano di Tecnologia, in English called Italian Institute of Technology, same like our IITs, where I did my postdocs. And the right side of the screen, you see my ERC logo, which was a funding agency for those projects. So it's really European Research Council. And I'm currently working as a research scientist, higher research scientist at the National Physical Laboratory in London. So that's my current affiliations. But whatever work I'm gonna show, was done at IIT in Italy. So as I said before, it's really not going into too much technical detail and just sharing you a couple of stories from my research. The first one would be how we develop like very good alkaline hydrogen evolution catalyst, and very good every time we develop something we say it's really very good, but as maybe Professor Bhosle know, it's not always very good, but for the sake of say publishing papers, say it's very good. But I will demonstrate how our catalyst really outperforms everything out there for hydrogen evolution reaction in alkaline media. And then the second story is about my current work at National Physical Laboratory. I have just started there in January, so it's really just 2 months. Tomorrow I will complete 2 months here, so I still trying to figure out what I will be doing here. But I will share some exciting research areas from NPL that you may be interested in. So really, why does the question of hydrogen comes up so often? Maybe it's high chance that all of you know about hydrogen, hydrogen energy, or hydrogen economy, or at least have heard the names. Maybe you don't know in details, but at least you would have heard the phrase hydrogen economy or hydrogen energy. So it's really boils down to use of non-renewable sources like petroleum, coal, or gas. And the gas prices, the petrol prices are always going up, never down. Petrol, diesel, or whatever you are cooking gas. And at the same time, this thing causes a lot of pollution. So there is a need to find alternative energy sources, and hydrogen is one of them, along with other sources. Hydrogen is really catching the eye there. So I'll be talking about how to make hydrogen and how to measure hydrogen really. As I said, we have to move from the left side to right side, really conventional sources, to photovoltaics, solar energy, wind energy, and alternate, and consequently hydrogen devices. So maybe everyone of you know that how we store energy. The primary source of energy these days is gasoline, that is petrol, or other sources like natural gas or nuclear power. So one of these alternative to store energy is hydrogen, and I will show you why hydrogen is really a big deal in next slides. So if you see here, I summarize energy density. It's really how much energy you can pack per kilogram of any substance. So lithium-ion batteries are the lowest here. The batteries that are in your phone or laptops, or really any portable devices these days, have very extremely low energy density. Probably that's why when you buy a phone with a higher higher battery life, is always kind of heavy. This is because lithium batteries have really low energy density, so it needs more material to pack the required energy. Then comes the gasoline, which has significant amount of energy per kilogram. And surprisingly, hydrogen has the highest, not surprisingly, but hydrogen has the highest energy density among them. So on the on the first show itself, it looks very promising for energy as an energy carrier or energy storage material. It's really 220 times better than batteries and 2.6 times better than gasoline. And the major problem with hydrogen is that, unlike say gasoline, there is no direct source of hydrogen, so you cannot just mine hydrogen really. But there is very simple way, electrolysis of water. So it's just really everyday water you use. Simply use electricity to split water into hydrogen and oxygen. But unfortunately, at the moment, current global hydrogen production is dominated still by natural gas and coal and oil. So the reaction shown on right side, like steam methane reforming and water gas shift reactions, these reactions run at very high temperatures, like 700 to 1000 degrees Celsius. They are highly energy intensive and produce a lot of greenhouse gases like carbon monoxide and carbon dioxide in the second reaction. So they are not really sustainable. So this is not a good way to make hydrogen. What other ways to produce hydrogen is really just, as I shown in the previous slide, it's just electrolyze water to produce hydrogen and oxygen. But only 4% of that hydrogen currently is being produced by electrolysis. Let's see why that's happening. What's the solution? So electrolysis of water is just really simple reaction. What you need is a separator membrane and then 2 electrodes, cathodes and anodes, and you just apply electricity potential and you get hydrogen at cathode and oxygen at anode. And you may ask why, despite being so simple, it's not being used widely. As I shown in previous slide, it's only 4% of total hydrogen production. It's just a really simple reaction, right? Well, many reactions or many things in life look simple by just looking at them, but deep down they are very complicated. So let's just move towards a little bit complicated part of water splitting or water electrolysis. So here I show a potential scale. So on a potential scale, splitting of water into hydrogen and oxygen should require 1.23 volts of potential. That is the thermodynamic potential required to break the hydrogen and oxygen bond, really. But no reaction is ideal. I mean, runs ideally, and we need to put some extra energy to split water into hydrogen and oxygen. This is due to various reasons. One of them being the kinetics of oxygen evolution reaction being really slow. So it requires some extra energy, as shown in this red part here. So this extra energy is called overpotential in electrochemistry. And on the cathode side, again, evolution of hydrogen requires, again, extra energy. So even though the thermodynamic potential requirement is 1.23 volts, we need much more than that to split water. So because of these reasons, the efficiency of water electrolysis is 70%. It was much less before, like started with 50%, I guess. But currently, due to research efforts to minimize this extra energy consumption, has resulted into water electrolysis efficiency being like 70%. Is 70%? It's really calculated by how much potential you put, is ratio of thermodynamic potential versus actual potential you need to put is about 70%. And this extra energy you need really depends on what kind of electrode material you are using. So going back to the previous slide here, really the over potential or extra energy depends on what kind of material this electrode is coated with, and it's true for both the sides. So you may wonder which material is really ideal, which material, if we use, will consume less energy and give us more hydrogen and oxygen. Well, we don't need to worry or search about it, because Paul Sabatier and Roger Parsons have already described what an ideal catalyst. So that material you coat on electrode we call catalyst, because it catalyzes hydrogen evolution and oxygen evolution reactions. So it's really, Sabatier said that an optimal catalyst binds the reaction intermediates moderately on its surface, not too strongly, not too weakly. What this means is that for hydrogen evolution, so I will be talking about hydrogen evolution reaction. So in that terms, the intermediate means protons, and we are reducing protons to hydrogen on the cathode. So it's really protons should bind moderately, not too strong, not too weak on the catalyst surface. And then Parsons demonstrated that the hydrogen evolution reaction catalyst, called HER catalyst, should exhibit really zero electron gives free energy, binding energy of 0 electron. What this means is that it's binding to the protons are binding to the catalyst surface, not too strong, not too weakly. So it's just optimal energy for hydrogen evolution. So he plotted a graph which is now called as a volcano plot because it looks like a volcano, and he really took a lot of elements, mostly transition metals, for say hydrogen evolution reaction, and he just plotted based on their activity. So y-axis is their activity. So the top is highest one. So as you can see, and the x-axis scale is gives free energy of proton binding. So it's really comes down to these metals like palladium, platinum, and ruthenium, mostly like platinum group metals that are at the top of the curve. What this means that they consume very less energy and produce more hydrogen and oxygen, which means less over potential. And other metals like cobalt, nickel, or copper, say silver, even gold, bismuth, they lie very much down the volcano, so they are not really good electrocatalysts. But the problem with this plot is not a problem with the plot, but the problem with these platinum group metals, that they are very expensive, extremely expensive, especially platinum itself, and then followed by palladium. Ruthenium is the least expensive metal among these. So it's really then I show you how to study hydrogen evolution reactions. So okay, so far so good. These metals are good. Some are bad, and we want to use them here in the as a catalyst on the hydrogen electrode. But really, how to study hydrogen electrode in the lab? Well, it's not that complicated. Basically, you need a 3-electrode setup, one of which is called reference electrode, one is working electrode, and the last one is counter electrode. The working electrode is your catalyst coated electrode. Reference electrode has a fixed potential, a constant potential, it doesn't change. So we can really study the potential required by hydrogen electrode here. This is the variable potential electrode, and then the function of counter electrode is just to pass the current, required current. So it's really simple setup you need, and of course these wires go to a machine called a potentiostat. Not really complicated machine, but you can precisely control voltage and potential, and see, you can actually study how much extra energy or how less extra energy you need to put to make hydrogen, really. So this brings up my first story, today's first story. So I will not go into like too much technical details to not make it too complicated for you, but just, so being an Indian, I always think about some kind of jugaad. Jugaad, you may know that is a kind of low cost materials or low cost thing that you use in your daily life instead of say availing expensive things. So I was just thinking what material I should use for hydrogen evolution reaction, because platinum is the best catalyst for hydrogen evolution. It needs very less energy, but the problem with platinum is that it's expensive and it's scarce. So it's not available in like say required quantity. So if you want to produce hydrogen on bigger scale, it's not really feasible with platinum. So I decided to use copper for this reaction. So what I did was I deposited some copper oxide on a titanium electrode, and this so in electrochemistry, what you do is one of thing you do is you just sweep the potential of your electrode to say for hydrogen evolution reaction to the negative side. So negative potentials mean that you are supplying electrons to your electrode, and which will reduce protons to hydrogen. So these are SEM images of the catalyst I deposited. They are in the form of nanoplates. And when I cycle this, so you see that the black one is first cycle. The potential is not so great. I mean, for an ideal hydrogen evolution catalyst, the potential to your hydrogen should be near zero. But as you see, the black curve is not so ideal, which means that it needs huge amount of extra energy to produce hydrogen. So I thought, okay, this material is not so good. And then I went for a coffee after starting this reaction, but I kept these cycles running. And what I found after coming back from coffee is that actually the curves are improving and going towards zero. Not really zero, but they're at least marching towards less energy area. So this really started a discussion in my previous research group as to why this is happening. And we characterize the material further by, say, again, electrochemical methods and SEM. As you see that there is a clear difference between first picture and third SEM picture. There is some kind of restructuring of copper happening. Also, I plot here the capacitance. Capacitance is really related to, say, active surface area of the electrode. So the black curve gives capacitance of the electrode after these number of cycles. Like you can see the capacitance is really increasing rapidly after cycling, which means that the electrode is changing for the better. It's increasing the surface area. Again, really some electrochemical stuff. We characterize the electrode further by applying different potentials by XRD. And we found that there is heavy restructuring happening, as you can see in this picture first, minus 0.1 volt. The initial plate-like structure completely changes to sponge-like structure after say 24 hours, keeping it at minus 0.1 volt. And this happens at every potential, maybe much less at minus 0.4, but it's really due to copper cohesive energy of copper being very less, which means that copper atoms don't want to stay with each other. They just want to move around in solution and then get redeposited on the electrode. So we find that after this kind of cycling experiment and restructuring, the catalyst is much better. The red curve here in the panel D. Again, some electrochemical characterization, the Tafel slope and impedance spectroscopy tells us that the catalyst is getting better and better after cycling. So so increase in only surface area was not the only reason why it showed better catalysis performance, but we also studied some surface characterization like XPS, X-ray photoelectron spectroscopy, and we found that a lot of titanium from the electrode is traveling through the copper to the surface of copper. It's really that in NaOH solution, it's etching titanium and it's making titanium dioxide particles, which along with copper are located at the surface. So a lot of titanium dioxide is located at the surface. And then we propose a mechanism why our electrode is better, gets better upon cycling. It's really titanium dioxide helping it acts as a co-catalyst, is like a friend who helps to split water. So titanium dioxide binds to hydrogen, sorry, not hydrogen, to oxygen strongly, and then helps splitting the water. And then these protons go towards copper, which then evolves hydrogen. So it's kind of say catalyst, co-catalyst, helping each other to produce hydrogen. Well, beyond this, so even if the catalyst is better, it's not the best catalyst still, because it's still far from zero, so still it requires much more energy to produce hydrogen. So the second, then we further thought that why not put some a noble metal, but which noble metal to choose, because all are expensive, really. But I found that ruthenium is like 10 times cheaper than platinum and has a nearly similar, as I shown in my previous slide, that has a similar binding energy to protons. Is nearly zero, which is required for like extremely good hydrogen evolution. So I developed a method to in situ prepare this electrode called copper and ruthenium. So it's really more like 92% copper and about 8% ruthenium. So we add less ruthenium to say save money, but at the same time we don't compromise on performance. So what happens in this case is that these ruthenium particles get deposited on copper electrode as shown in the top panels. Again, with some characterization called X-ray absorption, we show that there is some interaction between copper and ruthenium. And if we see the hydrogen evolution performance of these electrodes, we found that is even better than the benchmark platinum carbon catalyst. So platinum, as I told you before, is the best catalyst for hydrogen evolution. But we found that our catalyst is much more better than platinum. And it's better not only in terms of, say, activity, but the mass activity is really the amount of catalyst you use, and then what amount of current. So the higher the current, the better the catalyst here. So in terms of mass activity, our catalyst was better, copper, ruthenium. Again, in terms of price activity is really how much money you put into making a catalyst, and then how much performance you get is the just ratio of that. And our catalyst far superior than the platinum carbon because of low cost and high activity. And then we compare the activity of our catalyst with the literature, with the catalyst reported in literature, similar catalyst reported in literature, and we found that our catalyst is again lies really outperforms a lot of most of the reported catalyst is much better. And then not only activity, but the catalyst should also be stable. So we studied the stability of our catalyst for 100 hours, while the benchmark catalyst activity decreases rapidly in first few hours. Our catalyst sustains the activity up to 100 hours. And again, studying the morphology of our catalyst by SEM showed that the plate-like structure remains intact after 100 hours of hydrogen evolution, which means that which highlights its robust nature. So the catalyst is both highly active and stable. So at this point, we thought, why not protect it? So what protection means is that simply, why not get patent on this? We can sell this catalyst to companies or something. So really, we applied for patent, seeing the good activity of our catalyst. This patent was granted recently, I think last year. And then based on the patent, we thought that this catalyst can be further improved activity-wise and stability-wise. So we submitted a proposal to European Research Council that, okay, we told them that, okay, we have this catalyst and it's performing much better than the benchmark catalyst. So give us really some money to develop this catalyst further. We want to see it used in a industrial scale setting. So give us some money to develop a prototype of say water electrolyzer. So we wrote a proposal. So this is not me alone, but with my then supervisor, Professor Manna. And we got a grant of 150,000 euros to develop this catalyst further. And what's really happening with that catalyst further is that we again try to, just a moment, I need to hide. Okay, so what's happening here is that we again went into say basics of electrochemistry and really thought about how to improve this catalyst further to make it again much better. And we separated the roles of say current collector, co-catalyst and catalyst. And with these improvements, the figure you see on the right panel. So at this moment, I cannot show you what the actual catalyst is in this case because it's still under the work is still ongoing, and we have applied for another patent based on this. But really, the highlight of this result is that now we have a catalyst that is, I would say, to best of our knowledge, is the best catalyst in the world for hydrogen evolution reaction in alkaline media, at least in a laboratory scale setting. So as you see, the red panel again is going towards 0. So so it performs all the relevant electrocatalysts reported in the literature, and also we show stability for 8 days. So it's relatively very stable. Again, based on this, I cannot seem to, okay. Again, based on this, we got another patent, which was, I think, very recent, 28th of February, this was filed. It's based on this material. We got another patent, so we really want to push it further. So what's next for this catalyst? It's really now comes to use the catalyst in a really commercial scale alkaline electrolyzer setup, which somehow one of it looks like this. It's a really big, large scale. And whatever we have done so far regarding these catalysts is really test them on laboratory scale, but that's not enough. Now we are moving towards more commercial side of things and technological side of things. So we want to use it in a commercial alkaline electrolyzer setting. So for my next story, I'm not going into details of all the other projects that I did. It's really too much data for this sort of talk, but I will just move to my next story. So I will just briefly show some of our other works. I just like explain them in like 30 seconds each. So this one is related to making hollow porous and hollow particles of nickel cobalt selenide for oxygen evolution reaction. They perform, I would say, good for oxygen evolution as compared to benchmark ruthenium oxide. Then another project is related to making this quaternary nickel cobalt sulfur selenide particles for oxygen evolution reaction. Then another work is making hollow particles, again porous particles, to say maximize the surface area for oxygen evolution reaction. Another work, the same work for the electrochemical characterization, we showed that it's actually better than the benchmark ruthenium oxide, but the stability is not so great. And one more work. So there is such really too much stuff to discuss, but I will just skip to my next story. So here comes the interesting part. So whatever we were talking about before was about, say, laboratory scale settings. So research is like going on full scale to develop good catalysts for both the electrodes, study electrochemistry, study properties, but what's really happening in the market. So as I told you before, you may have heard this word hydrogen economy. So what really is hydrogen economy? It's just replacing your current fossil fuels with hydrogen everywhere. So here you use solar energy to split water, which is shown in kind of glass here, and then make hydrogen, and then you can use this hydrogen for, say, to run buses, really hydrogen fuel station. Just like you have petrol pumps, you will have hydrogen pumps. You use that hydrogen to drive your bus or car, and then use it in a fuel cell. So fuel cell is really just you can call the engine, hydrogen engine. So this fuel cell consumes hydrogen and oxygen to produce water and electricity. So hydrogen economy is all about using hydrogen everywhere. So this, and there comes hydrogen economy you see on London roads. So you see quite often these buses which are run on hydrogen. And also at my current workplace, National Physical Laboratory, we have this car which runs on hydrogen. We have a hydrogen refueling station. And the perks of working at NPL is that you can take this car out. You can use this car if you have some work related things to do in London. You can just take and drive that car. So about my current workplace, the second part of story is that it's a national lab. It's also called National Measurement Laboratory. It's just the goal is to help UK businesses, academia, universities for their measurement needs. What measurement means is that if you want to measure a specific property, for example, if you develop something new which you want to test if it's really better than the current benchmarks, the customers, called, say, third-party customers, companies or universities, come to us, the national lab, and we test them for, say, relevant relevant property. And the lab comes under the Department of Business, Energy and Industrial Strategy of UK government. And the department I'm working in is called Electrochemistry Department again. So I'm again doing the same things, but more towards the hydrogen, commercial side of hydrogen, technological and commercial side of hydrogen. So it's really the bottom part here. We study fuel cells, hydrogen engines we call, and water electrolyzers, again making hydrogen and oxygen. We study various electrochemical properties of the catalyst materials, or say the devices itself, to optimize them, to reduce the energy consumption by the devices, to improve the energy efficiency. And really the final goal, the UK government's goal is to go fully renewable by 2050. So like complete decarbonization of economy. They want to remove carbon from, say, all the fuels. So really use batteries or hydrogen to power, say, everything, basically from houses to cars to buildings to everything. So our goals align the goals of Electrochemistry Department align with the UK goals of UK government, and we help them to go fully renewable by 2050 by doing this kind of research in hydrogen economy. And the last panel, the last graph, really, I show you that. So this is predicted that until 2015, it's really like 28 years from now, the hydrogen will have market share of 20 to 35%. So there is a range. It's not like really defined range. It depends on how hydrogen technologies proceed further. But the goal is, or the estimated energy consumption using hydrogen would be in the range of 20 to 35%. So it's really huge amount. So the y-axis is terawatt hours of energy. So UK's total energy demand, and among that demand, our hydrogen economy is supposed to be, or predicted to be, contributing to about 35%, which is really high. And the work is ongoing to develop technologies, to measure technologies that really push the hydrogen in the market further. So that's my current work. I really cannot show you any projects that I'm working on currently because at NPL, because those projects are still ongoing and kind of trade secret, I would say. So maybe next year's conference, I would be able to show the projects really. So I guess I'm on time. It's 6:14 here. It's 45 minutes. Just 1 minute remaining, which I would like to thank you. Thank you for your attention. Thanks everyone really for attending the conference, and thank you to Samadhan again, to the principal of Shahu College, and to Professor it's really it is early morning, but it's hydrogen is always exciting, so it was really a pleasure talking. Thank you so much. And forgot to tell you, I'm open for questions. So any question?
Yeah,
just
Deepak, wait.
Shoot up.
Wait, I will ask the organizer whether You want to go ahead with question or not? Record, sir.
Yes, sir. If there is any questions from the participants, they can ask, sir.
Okay, please, all the guys, please raise your hand or you can comment on the chat box if you have any questions. I must thanks Deepak Shinde for a wonderful talk, and I will thank again at the end. But please, this session is open for discussion. Please, anyone has question, please go ahead. This is a problem, Gaikwad sir, in India. Student आपले विद्यार्थी खूप शाय आहेत.
Yes, sir. Yes, yes.
फॅकल्टी ध्यान देत नाही. कारण खूप मोठा टॉपिक आहे. हायड्रोजनवर बस चालते याच्यामध्ये. ओके, Deepak, I have a few questions for you.
Yes, sir.
Are you there? Okay. सर तुम्ही अनम्यूट करता का गायकवाड सर? दीपकला बोल देना.
Yes, sir. Yes.
Okay, thank you. Deepak, what is the source of, like when you're making the hydrogen, what is the real source to make the hydrogen first? Because in electrochemistry, how large quantity we can go? That is the first question. And second question, we have the 2/3 of Earth is occupied with water. Can we split the water to make the molecular oxygen and molecular hydrogen? What is your goal, main goal? Am I audible?
Yeah, yes.
Deepak?
Yes, sir.
Okay.
So the source is really that you can use any water. Water is available in plenty amount, but you need to purify that water to like really, the water should be really pure because the impurities from water can poison the catalyst. It's going on at the moment. There are kilowatt and megawatt scale plants to produce hydrogen, but yeah, you can use any water, but there is a purification step required to do that stuff. You cannot really use any water really. Yeah, water. And as I shown in my last slide, so because NPL is a UK government owned organization, I can only talk about goals of UK government and also some European Union. They are really pushing and putting a lot of money in hydrogen related projects, and they are expecting it to contribute up to say 35% of UK's energy demand by 2015. So it's really ambitious goal.
Ambitious, yeah. Yeah. We can't do it from India because our government is busy with making Ram Mandir, all the temples. We are developing temples. This is a very important topic for us. Yeah, you are not here is good. Otherwise, you will be making a Krishna temple next time. It's good. Please go and make success. All the best for you. I think there is any more question, guys? Any audience? Any question you can ask? No. He's our person.
Students are
okay.
Really shy. I was like same like them when I was doing
okay. I think you are in time.
Masters.
I think,
but really, if you have any questions, you can send me email. Dr. Pawar has my email. Your Pawar sir, Samadhan Pawar has my email. So just contact me via email or say Skype. I have Skype. You can contact me on.
Okay. Thank you, Deepak. It's wonderful work you're doing. All the best for you.
Thank you, sir.
And I will. Anand, तुम्ही काय करताय?
sir.
बंद करा ना ते. हातामध्ये दिलं म्हणजे तुंतून वाजायचे ना, काय तर चालूच आहे ना.
Sir, I have one question.
Okay, Anand, go ahead.
Sir, please unmute yourself, sir. Anand, sir, please unmute yourself.
Yes, sir. Yes, I am audible, sir. Am I audible?
Sir, तुम्ही बाजूला बसा सर, बाजूला बसा.
Yes, okay, sir. Am I audible, sir?
Yes. Go ahead.
Yes. Initially, I am very thankful to Deepak sir for very nice lecture in the green hydrogen production.
So I have one question. It is a simple question. It needs the potential energy for the splitting of water. Now at the final end, is it evaluated hydrogen energy can cover the consumed energy?
Yes, so that's basically comes to efficiency of water electrolysis, which is running at say 70%.
Okay.
So the current water splitting devices are 70% efficient.
Yes.
I have also seen some new devices that work up to 80% electrolysis efficiency.
Okay.
So it's really the device is getting better and better. For sure, it would not be 100% because of the kinetic limitations for hydrogen and oxygen production. But 80% is a good figure to say to start say scale water splitting to make hydrogen.
Yes. So I have one more question, sir.
No, I think Anand, you can send him email because the other lecture might get it.
Yes. No problem. Thank you.
Yeah. Okay.
Yes.
Thank you,
Yes.
Deepak. I will hand over to the organizer. Very wonderful talk. And please, Gaikwad sir, please take over.
Yes,
Madam,
sir. Thank you, sir. Thank you, sir. Thank you very much.
Thank you. Okay.
Thank you very much, Deepak sir, for sharing your deep knowledge with us. Your session was full of enthusiasm and valuable knowledge. Thank you very much. To deliver vote of thanks, I invite Mr. S.A. Shinde sir, the Assistant Professor from Department of Chemistry.
Yes. Good morning, everyone. I'm here to share vote of thanks on behalf of organizing committee, Rajarshi Chhatrapati Shahu College, Kolhapur. I would like to thank Dr. Deepak Shinde for delivering such an informative lecture on advanced electrocatalyst and measurement techniques for green hydrogen production. Actually, it is a very important because hydrogen as a green fuel is very, very important today. And the lecture was very thorough and very deeply explained. That's why I deeply say thank to Dr. Deepak Shinde. And I also thank today's chairperson, Dr. Sheshnath Bhosle, for chairing this session. Thank you.
Thank you.
Thank you, sir. I invite Ms. D.A. Maivekar Madam, the Assistant Professor from Department of Zoology, to introduce the chairperson.
Thank you, ma'am. So here I am with for the session second. I welcome all of you for this session too. And for this session, we are having Dr. Rahul Jamdade sir from UAE and Dr. Ashish Deshmukh sir as a chairperson for this session. Let me introduce about Dr. A.A. Deshmukh sir, Head Department of Zoology from Shivaji University, Kolhapur. The very active and motivating personality for all of us. He has completed his PhD in cell biology from Shivaji University, Kolhapur. He has qualified NET/SET exams. He has completed 3 research projects. Under his able guidance, 4 students have already completed their PhD. 1 is completing for the MPhil work, and the 2 students are undergoing the PhD work. 39 research papers are published in very high impact factors journals. He received various awards for his academic and research performance. His research interest is in the process of neurodegeneration, cell stress response and hormones, cell senescence and aging, intervention, and to slow down the process of neuronal aging. I would like to request Dr. Ashish Deshmukh sir to chair this session and also welcome and introduce about today's resource person. Thank you, sir. Over to you, sir.
Yeah, thank you so much, Deepali Malvekar madam, for nice words for me. Thank you so much, principal and my friend, Dr. Dubal sir, for giving me this opportunity to chair this session. It is really an honor to chair a session of such a great person like Dr. Rahul Zamdade. It's a great pleasure to introduce Dr. Rahul Zamdade, that he is the alumni of this university. He completed his BSc from Yashwantrao Chauhan Institute of Science, Satara. Then he completed his MSc from Shivaji University, Kolhapur. And then he pursued his PhD from from Paul Herbert Center for DNA Barcoding and Biodiversity Studies from Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. I have gone through his biodata and I'm very much delighted that many of his research publications are from most prestigious journals like PLOS One, then Springer's Biotech, Frontiers in Plant Sciences, and all of them, they are having impact factor above 3. Dr. Rahul Arvind Zamdade is working as a postdoctoral researcher at the Sharjah Seed Bank and Herbarium Environment and Protected Areas Authority, Government of Sharjah, United Arab Emirates. He worked at Sharjah Research Academy from 2017 to 2021 as a research specialist, and now he is simultaneously, he is working on developing a bioinformatics workflow using an artificial intelligence machine learning approach for species identification. For this work, he has an affiliation with the Ludwig Maximilian University, Munich, Germany. For presenting this research, Dr. Rahul received an international travel grant from UAE for the 8th International Barcode of Life Science, Norway. His work was published recently in the MDPI Plant Journal. Another article on similar approach is under review at the PLOS One. He is also actively involved in various projects in the field of molecular taxonomy, genomics, and transcriptomics with UAE University, University of Sharjah, Birla Institute of Technology, Dubai, and Goa campus, and Paul Herbert Center for DNA Barcoding and Biodiversity Studies. In his collaborations, he has published about 2,000 DNA barcodes and various research articles in high impact factor journals. So he has a very vast biodata, but because of time constraints, I will limit to this. So I welcome on behalf of all organizing committee of this international conference to Dr. Rahul Zamdade sir. Over to you, Dr. Rahul Zamdade sir. I request you to present your wonderful talk here. Thank you so much.
Thank you, Deshmukh sir, today's chairperson. Am I audible?
Yes, sir. Yes, sir. You are audible.
Thank you very much, Deshmukh sir, today's chairperson for my session, for introducing me. And I thank Dr. Dubal, the principal of the college, for giving me this opportunity. So with the permission of today's chairperson, I'll go ahead with my presentation. So
yes, sir. Please, please.
Yeah, let me share the screen.
Rahul sir, we are able to see your screen.
Yes. Okay. So, yes. So today's topic is artificial intelligence for accurate species identification. So actually, as you know, like my background is zoology. I completed my PhD in zoology. I have developed interest in bioinformatics during my PhD. And now I am in the botany field just because of the my expertise in bioinformatics. So what exactly we do over here? We are doing DNA sequencing of the flora of UAE, and we are making a barcode library to help identify the plants through the DNA barcodes or at the molecular level. So during this, we came across many softwares that can be used for classifying the barcode data. So I was able to use artificial intelligence and machine learning technique to classify some of the plant species, and I was able to classify it with a better way than that of the conventional techniques or conventional tools which are being used till date. So let's see how this process is done, and I have kept my presentation as simple as I can so that it is understandable by most of the participants. So computers are able to see, hear, and learn. So welcome to the future. This has been said by Dave Walters. So artificial intelligence is all around me. Today, we are going to study a subset of AI, which is a machine learning. So machine learning is a subset of artificial intelligence. We'll see how supervised machine learning technique would facilitate accurate species identification. Okay, so let us understand basically what is artificial intelligence. We'll go through the background, how this came up, how this term was found. So intelligence is demonstrated by machines. It can be like a natural intelligence of humans or animals. So for example, thinking and working like humans. So machines are able to do this way. So for example, speech recognition, problem solving, learning, and planning are few examples how the machines can demonstrate their intelligence. So they mimic the cognitive function of humans. John McCarthy is one of the founding father of AI. He coined the term artificial intelligence in 1956. But the journey to understand if machines can truly think began much before than that. The early AI research in the 1950s was done where Alan Turing suggested that humans use available information for problem solving and making decisions. Okay. So why can't machines do the same thing? And in one of his research papers, he discussed how to build intelligent machines and how to test their intelligence. So later in 1960s, US Department of Defense started using the computers to train the computers, and they completed the first street map and produced intelligent personal assistant in 2003. So this is long before the present Google Maps or Alexa. So this is the background of AI. Now let's see existing applications of AI. So so you may not realize, but artificial intelligence is all around us. So here are a few examples like Google Assistant, Alexa, Siri. So these are voice command systems. You might have used them before. Like for example, Facebook. So Facebook timeline uses a machine learning to customize posts shown to each member based on the number of interactions done by you and clicks and shares. So it will show the post, or it will show the advertisements based on your interaction. So many times you can see relevant advertisement come while you are scrolling through the Facebook. So this is why, because the machine has learned from your clicks and from your interaction, what do you want exactly, and it is showing the ad relevant to your interest. So this is how the machine learning in the Facebook works. Also Netflix, Amazon, Flipkart, these are recommending online offers and prompt us what to purchase depending on your search history. So whenever you search through Amazon or Flipkart, or even whenever you search through Netflix or Amazon Prime for the video, it learns, the algorithm learns like what you are interested in, and it can show the relevant or related searches that are more relevant to you. Next is like you all know, like Tesla. It is a self-driving car, and it is completely a product of well-defined artificial intelligence. Okay, so let's discuss about various subsets of AI. So what are the subsets of AI and how we are going to focus it today? So the subsets of AI, artificial intelligence, are machine learning, deep learning, and neural network. So machine learning, what is it? So it provides intelligence to machines with the ability to automatically learn through the experience without being programmed. So machine learning algorithms, I'll explain what are algorithms later on, but what does machine learning does? It can learn automatically by the experience and it doesn't need any programming. So programming is not done for this. Which is like done conventionally, which we are using in conventional tools. So this is difference between artificial intelligence and the conventional tools. So next, deep learning. Deep learning can be supervised and unsupervised learning, where the algorithm can learn through the supervised training by its own experience. So now what is done in deep learning? It learns by its own experience. As much as you feed to that algorithm, it will learn and it will experience what the data has to say or what information data has. It will reveal results accordingly. For example, image recognition, text translation. Like from image, it can translate text. So here this deep learning algorithm is used. Then language recognition. So these are some of the examples of deep learning. Next, the most advanced technique is neural networks. So what are neural networks? Neural networks are a set of algorithms and have been modeled loosely and thus after the human brain. They are named after the human brain. So computer scientists have designed them to recognize patterns in the data. Okay, so algorithms in a neural network might learn to identify photographs. For example, some of them have a label as dogs. So if you have photographs, set of photographs in which there are dogs and some are non-dogs. So the label is given for a dog, which are dogs, and another which are not dogs, the label is given as non-dogs or no dogs. So the algorithm gradually learns from the photograph of like how the dog is or what are the traits of dogs like teeth, four legs, eyes, nose, ears, fur, and tail. So this is the description of dog versus what are the other animals in the picture which do not have or do not match the traits. So it can differentiate from the traits accordingly. So they automatically generate identified traits. So let's understand this by a simple analogy. Let's not get confused. Okay, so I've brought an example of a simple analogy or a simple example which you have gone through your day-to-day life. Okay. So the concept of machine learning. Machine learning allows machines to learn from examples and experience, and that too without being explicitly programmed. So no programming is required. So here is the analogy on shopping of fishes. So suppose we are going one day for shopping of fishes, and you have to understand the details of all the factors that affect the quality of fish. So you have to decide how you will choose the best one. So this is your task. So these are the set of learning instructions to choose the best fish available. So these are the best, what we can say, characteristics to choose the good fish. And if the characteristics are false, then you don't need this fish anymore, or you will not purchase the fish. Okay. So what if we have to write a code for this? So let's think in a conventional way. So if we have to write a code, it will go in this way. If this, and if everything is good, fish is fresh. If not good, then fish is old. But what if the problem gets complicated enough? It might get difficult for you to make a manual of rules that covers all possible types of fishes. Okay. So this will take a lot of research and effort, and not everyone has much time. This is where like machine learning algorithms come into the picture. So instead of you writing the bunch of code, what you do is you feed the data to the generic algorithms or machine learning algorithms. So what it does, the algorithm builds the logic-based workflow based on the given data. So let's see what are these machine learning algorithms. An algorithm is a finite sequence of well-defined computer implemented instructions, like you give a set of input or an input example, and you have to provide a set of rules. So based on the rules, it will analyze the input and provide the output. Okay, so this is the way typically to solve a class of problems or to perform a computation. The machine learning algorithm is an evolution of a regular algorithm. So it makes your program smarter by allowing them to automatically learn from your data. So when we provide set of rules over here, the machine learning algorithm will learn from your data, and based on what it learns, it will analyze it through this algorithm, and it will provide an output or well classified result. So this works as follows. First, there are two phases. First is training phase. So you have to take a randomly selected fish from the market, and you have to record the or tabulate the physical characteristics with the features. Okay, so this is the training data. So to feed this data to machine learning algorithms, and it will learn about the fishes. Next will be training phase, testing phase. So now we have trained the algorithm. Okay, we have already trained the algorithm with enough data. So we should have data of n number of specimens to give confidence to that algorithm so that it predicts correctly. In testing phase, so next time when you go for shopping, you have to measure the characteristics of fishes, of the fish. One or two fish maybe. This will be your test data. You have to feed it to algorithms, machine learning algorithms. It will use the model computed earlier to predict the fish, whether it is fresh or old. So it will compute based on the training data, what it has got, how it has got trained from the data. In the same way, it will compute or it will predict which fish is older or which fish is fresh. So the algorithm uses the rules similar to manual rules. Finally, you can now shop the fish with great confidence. Okay, so algorithm has given you output based on n number of observations on n number of fishes, and now by giving a test or by giving a sample characteristics, you will get a very accurate result. So this is how the machine learning algorithms work. But there are different kind of what we can say methods on how we can make those algorithms work. So we'll see in further slides how we can manipulate these phases according to our convenience. Okay. So these are the what we can say features or what machine learning algorithm can do, but we'll not go in detail. Why? Because we will be today. Okay, today we'll be focusing on supervised learning. So supervised learning is, in its name, like you have to give some set of data which is having well classified features, and based on this well classified data, it will learn. So that's why it is supervised. So for the classification task, the machine learning program must draw a conclusion from observed values and determine to what category new observation belongs. So, okay, so in this, we will typically cover classification area. So for this, I'll give you an example, like while filtering mails as spam or not spam, the program must look at existing observational data and filter mails accordingly. Okay, so if you have done this before, you are sometimes recognizing mails manually as spam or not spam. So once you start clicking them as spam, for example, Gmail algorithm learns which messages are spam, or the messages that are spam, what kind of text is having or text is present in the spam messages, and it starts making or marking span by itself. So next time you don't need to mark such kind of messages as span, because it has already learned from your behavior. Like, yes, you mark this message as spam and you don't want it to be in your inbox. So next time it will automatically filter the spam messages. So this is the classification made by the algorithm. Okay, so in classification, we will specifically deal today with the diagnostic applications to recognize or to diagnose species. So first of all, image-based supervised machine learning for species diagnosis. So species identification is not exclusively the job of taxonomists and ecologists. It is required or is useful for large part of society. So identification is required by large part of society, from professionals like conservationists or biologists to the general public or nature lovers. So everyone cannot be a taxonomist or ecologist. So as species identification plays a vital role in recognition and protecting species to conserve the biodiversity, but the species identification by conventional method is difficult due to the specific lenient terms. Maybe it is time consuming and requires even expertise. So not all can do this. So it requires experts. It requires taxonomists who has gained experience through years and got hold to the this field of taxonomy. So, however, to obtain competitive species identification skills, as we discussed, it requires intensive training and experience. This creates hurdles for beginners interested in acquiring species knowledge. So, in recent years, image processing and pattern recognition have been introduced in the taxonomy. So, there are few publications out there who that interpret how this image processing can be used to recognize or to identify species. So this is the best example I found from the study of 2018. This is automated plant species identification based on images. So what will the plant taxonomist do when he is given this image of flower? Okay. So this is just the image of flower given to a plant taxonomist. What he'll do? He'll record the taxonomic characters of flowers in the given image. Okay, for example, petals, anther, filaments, stamen, pistils, sepals, and so on. And what the machine learning algorithm will do when we'll provide this image to that algorithm, so it will extract feature vectors through image processing. So you can see what are the feature vectors extracted by this algorithm. These are edges, blobs, which are textures, we can say, contours, and many other descriptors. So algorithm looks to that picture in a different way and a different angle, and versus botanist who has its different set of characters. So we combine these both characters together in the classification. So we'll see the fundamental steps of supervised machine learning, how these characters can be combined and used for the classification of the flowers based on images. Okay. Okay, so now the training phase, as we discussed before. So it has a set of training data set with the well identified images with class labels. So this class, these are class labels. Class label is nothing but the well identified by linear taxonomy. These are the class labels given by taxonomist or expert. So another are training images. So what algorithm will do now? It will develop feature vectors and will prepare its own set of feature vectors, and the feature vectors with the class labels form a single data set. When both things are given to the machine learning algorithm, it learns, okay, and during the testing phase, when we give the test image, what again algorithm does? It extract feature vectors from it, and again based on a predictive model or based on the learning, based on the experience what it has learned, machine learning algorithms can predict the species to which the image belongs. So basically it starts from two things. First, training data set and testing data set. For training data set, we need to have a well classified data for those images. And another, this classified data is given by taxonomists or botanists, and the well classified data with the feature vectors given by or identified by computer vision. So this comes together to form a complete data set. Through this data set, machine learning algorithm will learn like, yes, this species of flower appears in this way, it has this many characteristics. It learns from the images and from the experience of taxonomies. Now in testing phase, when the test image is provided, it also extracts some features from the test image and it starts matching this feature image to the given previously learned training data from previously learned training data. And when both things are included in predictive modeling, the result is given in form of a classification, or the classification is predicted. So you can see the classification is 93.9 to 99.8%. Sometimes this classification might be lower than this. So why the classification is not 100% accurate at test time? Even we are giving much of the characteristics like experts advice, then feature vectors are being extracted. Why 100%? We cannot get 100%. So this is a simple understanding. Like for example, why a student cannot get all the test questions correct even when the teacher has taught everything in the class. Okay, so until at the end, this is the algorithm which is learning like a human. It cannot be always 100% accurate, but the accuracy is far more better than the conventional algorithms. We'll see how in the later stage. So the deep learning has seen a significant breakthrough due to the availability of efficiency and massively parallel computing power of GPUs, like graphical processing units. So basically you need high power or high computing technology to process such kind of data. So however, large scale image data is necessary for training deep neural networks. So in order to train in order to train the algorithms very well, you need a large scale data. Small scale data can be error prone, or it might lead to what we can say errors and lower accuracy as compared to the algorithm which has very well knowledge or which has been trained by large scale data. Okay, so we'll see like DNA sequence based supervised machine learning for species diagnosis. So before we saw like how it can be identified from images. So this is actually the approach that we are implementing it over here, DNA sequence based approach. So we'll start with it. So besides species identification using imaging technology, emerging DNA sequencing technologies have made species identification more competent and affordable. So as the success of this molecular technique is is to distinguish species, it offers a great hope for identifying unidentified specimens. So DNA sequencing technology is very useful, and what it involves sequencing of very short standardized DNA sequence from a well-defined gene. So this area is really developing very well, and it is being used to identify species based on a DNA sequence as well as on the morphological characters. And when both the things are used together in the machine learning, to train the machine learning algorithm, they work very well. And the classification is also better than that of conventional techniques. So this DNA sequence based on molecular taxonomy has been termed as a DNA barcoding. Nowadays, DNA barcoding has become an invaluable tool in taxonomic classification and species identification. So efficiency of DNA barcoding technique is resolving technique in resolving animal and plant groups is different. Okay, it is different for the animal group and is different for the plant group. I've worked on both the groups, and like in animals, there is a mitochondrial gene alone that has been nominated as a universal candidate region or the candidate barcode region, and which has a very well efficiency in classification than that of the plants plant regions. Like plant cannot in plants, mitochondrial genes cannot be used for classification as they have shown the unsatisfactory performance whenever they have been used. So chloroplast genes are being used in plant group like RBCL and MATCase for the classification, and they have been nominated by Consortium of Barcode of Life. So these are the type of genes that have been particularly used. Mitochondrial cytochrome oxidase 1 in animals and RBCL and MATCase in plant groups. So the data generated or the sequences generated for those genes are being used further for the analysis that we are going to see today. So how DNA sequence-based PCR identification is done? Along with the selection of suitable barcode markers, as now we have selected, like suppose mitochondrial cytochrome oxidase 1 in animals or cytochrome B. This is the suitable barcode marker for animal. Or RBCL or MATK is suitable for plants, as we discussed before. Along with the selection of these barcode markers, it is necessary to select an appropriate bioinformatic method. So first is unsupervised clustering method, that is traditional method or convention that has been used through years for delimiting species, in which what is done? A DNA sequence is obtained, then genetic distance between the sequences is calculated through different methods. After the calculation of genetic distances, what is done? The clustering of the sequences is done, where the OTO picking methods are used. So clustering is done based on different methods like maybe PGMA, K2P, and so on. And once the cluster is prepared, some softwares or some programs are used to pick the taxas from those clusters. So this is the kind of classification that can be obtained through traditional method. What happens in another method, supervised machine learning method? Here, DNA barcode library or a training dataset is prepared. We need a training dataset for, as we discussed before, to train the algorithm. So we prepare a barcode library from which feature vectors are extracted. So here there are two sets required, as we discussed, training set and test set. So from the training set, we create a set of feature vectors. So what are those feature vectors in DNA barcode? The character strings of sequences, like A, T, G, C. These character strings are the feature vectors if we give the data set in form of characters. And we can also calculate frequencies of those nucleotides in the data sets, which are called as k-mer frequencies. So there might be two data sets in DNA sequences, character string data as well as k-mer frequency data. So the feature vectors might be the set of characters or the set of k-mers. So these feature vectors are being fed to the machine learning algorithm. And next time when the set is given, the test set has an identification. You can give a certain identification, which probably maybe you're sure or not sure. It doesn't matter, because at the end it is going to classify it very well. But the DNA barcode library training set needs to have proper identification, proper classification belonging to the specific sequence that it has been identified. So this is a barcode data set, but test set, you don't need to worry like whether I have classified the sequence properly or whether does it belongs to the same species or not. So why this is? Because ultimately it is compared, it will be comparing test set to the training set. So in the training set also the feature vectors are extracted. This is just for comparison. It is required to compare with the feature vectors obtained from training set. So when it is fed to machine learning algorithm, it predicts the classification. The classification predicted based on comparison with training set. Another method, what could be another method that we could implement? So like many times, like it is not what we can say in reality, like you will always have a very well trained data set. This should not be always happening, of course. So you don't have very well trained data set, and you have some species identified properly with large number of specimen to species ratio, but some species to specimen ratio is very less for certain species. So you have not very well balanced data set. So in such cases, what we can utilize complete barcode data set, and there is no need to separate the training and test data set. So in this, we will do same as we did before. We have to extract feature vectors. Then what again we have to do? We have to split your data into train and test set. So this is like a random splitting. You don't need to provide like exactly where we should split the data. So we have to consider like you have to tell the algorithm like please consider my 80% of data as a training set and 20% of data as a test set. So accordingly, it will calculate and analyze the algorithm. Next, again, I don't know like whether the data set, how much data set should I add for as a training data set and how much data set should be for test set. So this is like what used to happen, like if we don't have what we can say good species to specimen ratio again, if we don't have very well developed barcode library, we are just we have just started to develop this DNA barcode data set, and we don't have much data to allot it into training and test set. So and this time what we can do, we can allot complete data set as a test set. And this method plays very well. So now what we have to do, we have to select an option of cross validation. So what cross validation does exactly? Cross validation will validate each and every specimen in the data set to other species or other specimen in the same data set. Suppose species A has 3 to 4 specimens. Every specimen of species A will be matched with all 4 specimens. And this way it will match again for other species and to see whether the classification for the species A is correct or not. So this cross validation is done into X number of times. So maybe you can give an option of you can cross validate it for 1 time, 5 times, 10 times. 10 times is a standard method. So we usually use 10 times cross validation. So we have a confirmation like through each iteration of validation that the analysis that is being done is having a great confidence and will be having best predictor result. So in this way, after the cross validation, the machine learning algorithms will predict the classification, and it really gives good results. So suppose like we have seen now 3 types of classification techniques. First is when you have very well stable or well developed data set, and that you can classify your data set in train and test set. Second is like you don't have confidence upon your data set, but you know like yes, I can dedicate this much amount of data to this much amount of data as train and test set, and you can use that method for splitting your data. And another is third one is cross validation, where you don't have much confidence about how approximate your data set is having the how the species to specimen ratio, or whether it is having accuracy in the classification or whatever it is. So such kind of random data set can be utilized for cross validation techniques. So we'll see how the results of cross validation are predicted further. But before going ahead to see how results are predicted and how the analysis is interpreted, we should know the models of classification. I'll not take you into the mathematics of machine learning. It is very difficult to understand even for beginners. So let's understand the theory behind the mathematics. So how the classification models are, how they look like, and when to consider them. So you should be sure to include the model and it should be the best fit model for your data set. Otherwise, you will not get the results that you have expected. So it's better to select a model before you proceed. So this model or an algorithm, what we say, looks like this. So here we have taken an example of 3 models. First is support vector machines. This is a function. We can say it falls in the category of functions of support vector machine. So what is support vector machines? SVM. So it calculates largest minimum distance between 2 groups. So here are 2 groups. You can see clearly, like one is plus, another is minus, dedicated by these signs. So the largest minimum distance between the 2 groups is predicted. And it is used to classify data points by finding the best hyperplane between them. So this is a margin, or we can call it a threshold. So the best threshold value is predicted between these 2 data sets. And based on the threshold value, the algorithm classifies the data. So we don't need to give this threshold value or the margin of hyperplane to the algorithm. We don't need to do this manually. So it learns from the data set. It learns like how these 2 species or 2 groups can be differentiated and at what distance they should be placed apart from each other. So this algorithm is intelligent enough to learn from your data. Second is random forest. This is a classification tree model, as you can see clearly from the picture. So decision tree, this is a decision tree. So what happens in this model? So attributes with the smallest entropy, any randomness, is selected and then split into split to produce subsets. So the subsets can be like from roots to leaves. Leaves are the species. So further proceeding from root to leaves is a set of decisions that led to a classification of specimen. This can be transformed with if-then rule. So decisions are being made by an algorithm to split the specimens or the species in the data set, and then the decision is made accordingly by finding the best match in the data. So random forest consists of large number of individual decision trees. So you can see there are many decision trees predicted by the algorithm. Each individual tree is a random forest which splits out a class prediction. So there is each individual tree which has its own class of prediction, and the class with the most votes becomes our model of prediction. So the best tree is selected out of those which is having the best possible scores, highest scores, matching to the if you give the training set or if you do the cross validation. So the tree with best scores is considered as a perfect match or a suitable match. Next is KNN, or K nearest neighbor. This is a lazy learning algorithm. It doesn't need any training data points. All data used is as a test set. So as it says, it's a lazy learning. It doesn't need any data points. No data points are given. All data set is considered as a test set. And the distance between the closest K point is calculated using Euclidean distance measures. In this way, the KNN algorithm works. So as we have seen the models, let's see the case studies that we have done so far. So how machine learning algorithms could assist in achieving accurate identification. This was our topic. So this is the first case study. We have done DNA barcoding of freshwater fish fauna. And we have used that data set for the classification through machine learning technique. So as we have discussed before, like for the fishes or animals, we use mitochondrial CO1 gene, mitochondrial cytochrome oxidase G1 gene. So we have sequenced this gene for the entire fish fauna that we have collected, and we have prepared our barcode data set. So this is the workflow, how the process goes. So the taxonomic assignment is done by two methods: clustering method, which is like conventional method, and supervised machine learning. And in the supervised machine learning, we use character-based method. If you remember, we discussed before two methods: character-based and K-MER-based. So this is character-based method. So in this, we have used the cross-validation technique. So cross-validation is being implemented with 10 folds of cross-validation. So 3 steps are included in this kind of analysis. First is evaluation of classifiers. So we have discussed classifiers before. Classifiers are the models like SVM, KNN, or random forest. So these are models, and we consider them as a classifiers. So first of all, we'll do evaluation of classifiers to see which classifier fits best for our data and which gives higher possible classification results. So in step 2, what happens? We will employ classifiers for species identification. After getting after finding best classifiers, we have to utilize those classifiers to analyze against the data. And step 3, we will calculate the precision of classifiers, how the classifiers performed throughout the analysis. And the classifier which has performed better can be considered as the best suitable classifier for your data set. So step 1, here you can see we have evaluated the classifiers. So here we have used 6 classifiers. Okay, SVM, we have seen it before: random forest, KNN, decision tree, decision table, and knife base. So these are the classifiers that we have evaluated. You can see the accuracy of the classifiers. You can see this SVM has accuracy more than 95%. Same for random forest and KNN. But other classifiers show declined accuracy. So that's why we didn't consider them. So we eliminated these 3 classifiers and we consider only 3 classifiers: random forest, SVM, KNN. So yes. So employing classifiers and their precision. So first, we evaluated classifiers. So this is second step, employing classifiers. So how the classifier should be employed for species identification. So the set of DNA sequences is given, from which the feature vectors are extracted. Feature vectors, again, character strings. Okay, so we use character-based method for determining feature vectors. So feature vectors are extracted from the character strings, and we used cross-validation technique. So through the cross-validation technique, this machine learning algorithm was implemented. We implemented three models, right? 3 methods: SVM, KNN, and random forest. So after its execution, we will get a classification. The classification will be predicted. Okay, so after the classification is predicted, we have to calculate the accuracy of the identification. What was the accuracy of identification, and how to consider whether the method you implemented is accurate and it's well suitable for your data set or not. Here you can see in this figure, the method 1, method 2, and method 3, these are unsupervised methods, which are conventional methods. But here you can see SVM, random forest, and KNN, these are supervised methods. You can see SVM and random forest have shown higher accuracy. Accuracy in the sense of recognizing true species. How accuracy should be considered? Accuracy should be considered in the sense of recognizing true species. It should be considered on recognizing the percent of identification, 100% or less even. So in this way, we consider the accuracy of identification of classifiers. So this was I was talking about true positive rate. So the accuracy again, so the precision of the classifier again depends upon the recognition of true positive species. Whether the species recognized has the highest confidence in it. So if it has highest confidence, it will show true positive rate of 1. you can see like most of the species, like we have analyzed about 81 species over here. From the 81 species, you can see like most of the species have been classified accurately, which has a value of 1 to positive species. So, so this is the step 3. So this way, the machine learning algorithms can be implemented correctly. First, evaluation. Second, employing those classifiers. And third, calculating precision of those classifiers. Second case that I would like to show you is evaluation of Arabian plant barcodes that we did recently. We published this article. We faced issues in this data set. I'll tell you what were the issues. So first, let's see the case study and workflow of analysis. So we retrieved data of RBCL and MATK barcodes from NCBI Gene Bank. So we were able to filter the sequences in NCBI Gene Bank by applying filters like those sequences should belong only to the Arabian countries. So we consider 8 to 9 Arabian countries from the Arabian Peninsula. And the data set was prepared for RBCL and MATK barcodes only. We implemented two approaches, alignment-based approach and alignment-free approach. Alignment-based approach, like we have conventional method of clustering. Then we have supervised machine learning method where we use character-based method for generating the data set. And another is alignment-free approach. So basically, in plants, the sequences have indents, insertions or deletions, especially in MATK. So MATK sequences have insertions and deletions. So there are gaps in sequences. Some sequences are of uneven length. So as we are downloading sequences from NCBI Gene Bank, the data cannot be trusted to its 100%, right? It might have gaps, it might have different lengths. So to minimize the error rate, we have to implement alignment-free approach. So this is Kramer frequency-based approach. In this, we use 3 different methods to generate the feature vectors. Okay. So logical alignment-free algorithm, gappy kernel, and mismatch kernel. So these were the 3 methods that were used to generate feature vectors. So they are specifically used to analyze alignment-free datasets. So datasets with gaps and uneven lengths can be analyzed easily through this methods. So now we have 2 datasets: alignment-based, which is well aligned 1-to-1, and alignment-free, which is not well aligned. So we'll see the example of the alignment and alignment free. Let's make it more simple. So we have seen the DNA barcode data sets of only one type. This is aligned data set. So this means grammatically correct paragraphs. What is aligned data set? These are grammatically correct paragraphs and which are meaningful. But what if alignment is not correct and data is scrambled, which might be meaningless? So this is like you have an English paragraph, but the words in the paragraph doesn't make sense to the reader. So this is alignment free or unaligned. So to make a sense out of the paragraph, alignment free approach would be valuable. So we have used 3 alignment based methods of Kramer counting or to generate feature vectors. So okay, one more thing I would like to highlight in this, like we discussed before, we should have enough data and number of sequences and number of species to get a confidence or to gain a confidence in the classification, right? Exactly opposite was observed for this analysis, data set over here. Why? Because this is as a public repository data and it doesn't has a balanced data set. I'll show you how, which ultimately affects the what you can say, the behavior of classifiers, resulting into lower rate of classification. So I'll show you this one. This is the figure which clearly shows like how the sample size can affect the efficiency of the classifiers. Over here, you can see this is one means one species. Though, so there were 150 individuals, 150, sorry, there were 150 species with one individual. So one is the individual or specimen. So for one specimen, there were 150 species available on the public repository. Then two individuals, there were about 82 species with two individuals, and this is the accuracy. You can see the gray and yellow bars. This is the accuracy of the classifiers. So you can see the accuracy increases with the increasing number of specimens per species. At the end, if you see, like, there are more than 10 specimens, accuracy is highest, but these species are less, 3 species. So this was completely unbalanced data set. We had lower number of species to specimen ratio, and it reflected our results. I'll show you. So first of all, as you know, we have to evaluate classifiers in step 1. This is the result of evaluation. We use this many classifiers, our models. Step 2 is employing classifiers. We employed the classifiers on our sequence data sets. As you know, we use 2 methods to create feature vectors, like character strings or k-mers, and it was implemented through cross-validation. And when it was classified to machine learning algorithm, we got this kind of results. So accuracy, you can see, like, accuracy was very less, 43, 40 in RBCL. In MATK, just don't look, it is very less. Why? Because the species to specimen ratio is imbalanced, is not good, which is very much required in biological studies when you analyze at the large scale. Even when you go for DNA barcoding or molecular studies, you need to have a very good species to specimen ratio. But you can see machine learning algorithms have performed here better, not good, I say, better than that of other unsupervised learning algorithms. Here you can see 29, 34, these are the results of unsupervised learning or conventional methods versus these are the machine learning algorithm results. So they have performed far better way than that of conventional methods. So what we did, what we have to do, as our data set was imbalanced, what we did, we had to create a balanced data set. For creating a balanced data set, we approached some studies which have already published the data set, and the data set is very high quality and has equal amount of species to specimen ratio. We use the data set, we filter the data set to make sure we have absolute species to specimen ratio, and the results were very good. We were able to get results about like more than 75% accuracy. But here you can see the accuracy is very less. So this was again published recently in Plants, Evaluation of Arabian Vascular Plant Barcodes, Precision of Unsupervised and Supervised Learning Methods Towards Accurate Class Identification. You can go through this publication. We have mentioned each and every step, how it is done, how we mine sequences, how we retrieve sequences from database. And this is completely dry lab data, dry lab analysis. Dry lab means we didn't include any kind of wet lab or laboratory analysis. This was done completely on computers. So, and even we didn't generate data by ourselves. Data was available already and is available on the public repositories like NCBI Gene. We have to just figure out what kind of data set you can use for analysis, and you can throw it into the machine learning algorithms. They will calculate it for you and they will predict the results. So we faced issue like having less species to specimen ratio. We compared it with the best available balanced data set, and the comparative results have been published. We have recommended researchers from Arabian Peninsula to generate more and more barcodes so as to stabilize the barcode data set for the Arabian plants. So we have endorsed this through our publication. So So there are similar publications like how supervised machine learning technique is used in species identification. You can see like there are many publications out there, but not not much publications have shown like how should be a standard workflow in order to analyze your data beginning from the evaluation of the classifiers. So yes, you can refer our publication for better results. Okay, yeah, I have something over here. Okay, in this publication, I have some notes for this publication. So what kind of data set they use and what analysis they did. Okay, so in this paper, they analyzed DNA barcodes of fishes and bats from protein coding cytochrome oxidase 1 gene and from rust, fungi, and brown algae with the non-coding nuclear internal transfer spacers. So they concluded that machine learning methods significantly outperform existing neighbor journey or maximum likelihood methods. So the machine learning methods outperform the conventional methods for both coding and non-coding barcodes. So this was the result of this publication. Another was like supervised DNA barcodes, species classification analysis, and comparison of results. In this publication, they analyzed 7 different data sets and showed that how supervised machine learning methods are promising candidates for handling DNA barcode species classification problems by obtaining excellent performances. Here they demonstrated DNA barcoding effectively and propose this technique as a promising tool to combat illegal logging associated threats. So their study basically showed that machine learning algorithms provide higher identification accuracy and are cost effective enough for the forensic applications over the other analytical methods. Okay, so how can you get hands on the machine learning thing? Like as you have seen, like what kind of analysis is being done, what we have done so far, and how you can get hands on the machine learning thing. So as I told you, like we have retrieved sequences for Unsupervised DNA. This is for dry lab. If you have existing DNA barcode data, it's well and good. But if you don't have, you can just go to any public repository, maybe GeneBank or maybe protein database. Even you can implement this algorithm for protein classification too. Then begin with the protein coding genes, align sequences in the Mega, which is a very good software and freely available. Then you can convert the aligned sequences to feature vectors, and we discussed throughout feature vectors. So the feature vectors are required to be there in order to feed the data set to machine learning algorithms. So feature vector is nothing but the translation or conversion of your data to the suitable format that machine learning algorithms can accept. So convert aligned sequences to feature vectors using faster to Weka converter. This is available freely online. Then you have to download and install Weka software. Weka software is being used for years for this technique. It is a very good tool for testing, machine learning testing tool. We have also used this for the previous publication that we have just seen. Then follow the instructions for installation and uses. So this is very simple. So okay, so this is Weka graphical user interface. So most of the time, we have to use Python for analysis. We have used this, but it is not always possible for every user to implement it through a programming language. So this is a very good user interface. You can just go online, you download it, install it, and it's very easy to operate. So it has different applications, Explorer, Experimenter, and so on. So through Explorer, you can open your dataset and you have to select the classifier. Just go to classify to choose the best method. We have seen, like we have discussed 4 We have discussed 4 models that can be used, 4 classifiers, out of which we have selected suppose random forest closure. After the analysis, you will clearly get results. I have shown it like correctly classified instances, 15, which is 75% out of 20. It's classified 75%, right? 15 species were classified correctly. Incorrectly classified instances are 5, so 25% are incorrectly identified. These are all statistics like error or anything else that you can consider. But again, apart from this, you have apart from this, you have the accuracy by class, and many results you can just go and test and see how these classifiers perform. And if you have any issues, you can just email me, drop an email. I'll help you to solve this. So this is like how machine learning algorithms could be trained for assisting future taxonomists. So with the digital imaging technology, they can assist through a cost-effective and rapid sequencing technology in developing DNA barcode library, then developing the informatics technology to high configuration workstations and quantum processing units could assist the effective implementation of MLA, machine learning algorithm. So if we have a good setup of informatic technologies, we will implement the machine learning algorithms in much better way. Altogether, above associations could assist future taxonomists in accurate species identification in a better way. So with the growing data, this is very important. The data needs to grow, and data, the good reference library is very much required to train the machine learning algorithms effectively. Unfortunately, if we lose trained taxonomists from our society, then trained machine learning algorithms could assist the research community in the better way, maybe in the near future. So, okay, so I'll not show much. This is our project where we have kept our barcodes. Last not but least, this is the thought from Jan B. Kuhn, professor from New York University. Our intelligence is what makes us human, and AI is an extension of that quality. So happy learning. Thank you very much. Yes, over to the session.
Topic is open for discussion. Audience can ask the questions. Dr. Rahul sir, it was a very excellent talk, and that too also in a very simple, lucid way. Although it was a very highly technical topic, but you made it very simple.
Thank you very much. I was intended to present in this way because before this I tried to explain it in one workshop, and I came to know from the feedback it is very difficult to understand this terminology. So we terms and all, and we tried to present it in a simple way.
But you know, you made it very, very simple.
Thank you.
Participants, you can ask a couple of questions. You can even text your questions in the chat box.
Hello, sir. I'm having one question.
Yes.
Hello, Rahul, sir.
Yes,
can we distinguish between the two twins by using this technique?
See, we basically need characteristics. Okay, we need to have a trained data set. We need to train those algorithms. So if we have a well classified data for the distinguishing of two twins, you should have very well characterized data. So if you have it, you can use them to design feature vectors. And once the algorithm is trained, then you can use any kind of test data to see whether they can distinguish or not. So any kind of data, even integer data or imagery data can be used. Just we have to extract feature vectors out of it, and once they're extracted, it can analyze any kind of data. Yes.
Thank you, sir.
Is there any question? If not, shall we go to concluding remarks? Is there any question? Malavekar madam, can you hear me?
Yes, sir. Yes, sir. You are audible.
Yes, sir. Yes, sir.
Yeah. If there is no any question, we will go to concluding remarks.
Yes, sir. Yes, sir.
Yeah. Dear Dr. Rahul Jamdade, sir. Yeah. Is there anybody?
No.
Dear Dr. Rahul Jamdade, sir, on behalf of all organizing committee of this international conference, I'm really grateful to you for your very excellent talk. You had covered all minor details of artificial intelligence, including machine learning, deep learning, and neural networking in artificial intelligence. Besides this, you had given a very simplified way of understanding that how artificial intelligence can be used to analyze the quality of the fishes, whether the fish is fresh or not. Even you have added your very interesting example of use of artificial intelligence in pattern recognition in taxonomy. Nowadays, every one of us know that in taxonomy studies, we cannot directly go and capture the animal. Earlier, people used to do it and bring the flowers or even animals, preserving them in formalin. But now, when we do such type of practices, then that we really cause harm to the biodiversity. So nowadays, such type of collection of plants and endangered organisms is strictly prohibited. So what a taxonomist depends on is the photography of that particular specimen. So you had given very excellent knowledge about how a photograph can be used for, how artificial intelligence technique can be used to identify a species using a given photograph of an organism. Further, you have added that how DNA sequence-based species identification is useful for taxonomic studies. And finally, you had given a very, what I can say, very good information about how we can go for hands-on training program in machine learning using a very straightforward approach. Here you had given the demonstration also. So I'm sure that every one of us who are working in such type of studies, particularly in biodiversity and species identification, Rahul sir, your talk will be very, very helpful to all participants. Thank you so much for giving your valuable time for this conference. And I'm very much grateful to you, as well as I thank all organizing committee for giving me the opportunity to chair this session and to listen very lucid talk of Dr. Rahul Jamdade sir. And as and when it is possible to meet physically, now this pandemic also is now this virus became a very used to virus, like a common influenza virus. So hopefully we will meet in person in coming days. Thank you so much, sir. Thank you so much.
Sure, sure. Thank you very much, Dr. for your kind words, and I really appreciate that. I thank you, organizing committee and Dugal sir, for giving me this opportunity. Thank you very much.
Thank you, Dr. Rahul sir. Now to deliver the vote of thanks, I invite Miss J.R. Katkar Madam, the Assistant Professor from Department of Zoology.
Good afternoon, all. I am Ms. Katkar Jr., Assistant Professor in Zoology. I indeed feel honored and privileged to propose a vote of thanks for this session. Second, because of the paucity of time, it's practically impossible to thank each and every person. I express my sense of gratitude to Dr. Ashish Deshmukh sir, Head Department of Zoology, Shivaji University, Kolhapur, for chairing this session. Second, thanks for giving us your valuable time. I also deem it my privilege to thank you from the core of my heart to our resource person, Dr. Rahul Jamdade, sir, Shara Seat Bank and Herbarium, Government of Shara, UAE. You explained artificial intelligence for accurate species identification. Thank you, sir, for giving us your valuable time from your busy schedule. Thanks for all the participants. Thank you, one and all. With this, I will hand over further program to our anchoring, Madam.
Thank you, madam. Now I invite Dr. Smita Zubey, madam, the assistant professor from Department of Botany, to introduce the chairperson.
Thank you. Thank you. Good afternoon and a very colorful welcome to session 1, invited talk 3. I said colorful welcome because there are two persons who are chairing this session. One is Dr. V.D. Zadav, and second person is a resource person, Dr. Pham Quang Hong, who is from Vietnam. And colorful in sense that the both ladies are working on different types of the forests. Especially Dr. V.D. Zadav ma'am has worked on Melghat forest, which was once upon first a national tiger reserve in the India. And so I'm here to talk or introduce Dr. V.D. Zadav ma'am to all delegates. She is head of department, Shivaji University, Kolhapur. Am I audible?
Yes, ma'am. Yes, ma'am.
Yes. She is head of department, Shivaji University, Botany Department, Shivaji University, Kolhapur, and has worked on, as I told, she has worked on the Melghat forest on the medicinal plants. She has a extensive expertise on the medicinal plants, the branch called as the ethnobotany, pharmacognosy, nutraceutical values of the plants. She has published more than 70 papers in the national and international journals. Her citations are more than 500 and H index is 10, I-10 index is 11, and papers presented in the conferences, symposia and workshops are more than 100. RG score is more than 20. And one thing I want to mention about these indices is these indices counts in the values, but value of her research is counted to the public people, public as well as the medical practitioners, whom we call as a Vaidya. Because the way in the plant taxonomy, there is ambiguity in the name of the plants. Same way, the medical people who are working in the field, they are called as a Vaidya. Medical practitioners have also ambiguity in the identification of the plants. Because many a times, one plant is used for many diseases, like 20 diseases, one plant is used. Same way, one disease is also cured by more than 30 plants along the western ghats of the Maharashtra. When her past work is concerned, when she was working in the Melghat area, it is about 61 villages with more than 10 tribes where she has worked on the plants of the Melghat. But presently, she is working in the western ghats on the medicinal plants. Her present research work is multiplication of those medicinal plants. Her extensive work is on some important genera. I'm not taking species of the those plants like Caparis, Holigrana, Ceropegia, Todalia, some edible tuberous plants. She has also worked on Clitoria, Ficus, Elagnus, Grevia, Xanthoxylum. So, multiplication of those medicinal plants, it is her present work. But before that, she has completed more than 9 research project works, in which she has worked on DRS phase 1st, 2nd, 3rd. Presently on 3rd, she is starting her she has started her work, in which lead botanical garden is one project. Second one is multiplication of those medicinal plants, especially a brachysteelma. Third one is plantation and a retransplantation of some mature cutted trees to the different roads of the Kolhapur under IRB. She has supervised more than 8 PhD students, and presently also 8 PhD students are working under her on ethnobotany. Recently, she has got a very special award, which is not available. Such award is not existing all over the state of Maharashtra. The award is National Distinguishing Research Award in ethnobotany, because ethnobotany, mostly the people from North India have started the branch, but some representatives are present in the Maharashtra, and madam is one of it. From Melghat to the Melghat Wildlife Sanctuary to the Western Ghat, where she is also working on the Radhanagari Wildlife Sanctuary. In this all over journey, she has contributed many more things to the Department of Botany as well as subject of the botany. She has got some awards in her credit, like Young Distinguishing Scientist Award. Apart from just I told that a new award, which is a Distinguishing Research Award. She has carried out some extension activities in the department, which are very important. And apart from that, as an administrator, she is the head of the department. For year 2010 to 15, she was elected as a Senate member of the department of the Shivaji University, Kolhapur. So with this, I can say that we are very lucky to get Professor Dr. V.D. Zado ma'am as a chairperson of this department. And one thing I can mention that indices, research gate scores, all are different, but on practical level, when some medical practitioners are coming towards her, the madam is only one answer to her. So we are very lucky. So right now I'm giving this screen and mic to Dr. V.D. Zado ma'am. Hello.
Thank you, Smita. Can you hear me?
Yes, yes.
Can you hear me?
Yes, ma'am.
Okay. So first of all, I'm very much thankful to Smita for giving a nice introduction. So good afternoon, everyone. A very warm welcome to delegates and participants in international conference on advances in science and technology, which is organized by Rajeshri Chhatrapati Shahu College, Kolhapur. I am very much thankful to Dr. Gozare and College Authority for giving me an opportunity to work as a chairman for the invited online talk of Dr. Pham Madam. So I welcome today's speaker, Dr. Pham Madam. She is a coordinator of Research Center for Greenhouse Gas and Climate Change, University of Science, Vietnam. It's a privilege to introduce today's speaker, Madam. So Dr. Pham Madam, she is working currently she is working on bamboo leaf litter standing crop and its decomposition. Earlier, she has worked on various projects in their country. Among them, her previous research experience, including conservation and sustainable utilization of wetland resources in national park, ecosystem functioning of rehabilitated versus natural mangrove in Kanjio Mangrove Biosphere Reserve, biodiversity in coastal water in Kamau province, biosphere, biodiversity in few inventorying the composition and assessing impacts of exotic weeds at some national park in Vietnam. Dynamics of the green belt in the frame of coastal changes along the southwest coast of Vietnam during projects. So she is working currently, earlier I told you, was a bamboo litter standing crop and its decomposition. She has done her PhD from Bremen University in biogeochemistry under the guidance of Professor Ruben Jos Lara, GMT Bremen, Germany. I am proudly telling you She got the award as a certificate of merit and reward for excellent achievements in science research conferred by the University of Natural Sciences, National University, Ho Chi Minh City in December 2016. She has published more than 7 research papers in international journals, and she has attended training courses on mangroves, wetland ecology, and nutrients in mangroves, conservation of forest and genetic resources. So today we have with us a great personality in this lecture, and we will listen to Dr. Pham Madam and her topic. Today's topic is the changes in sediment nutritional status along the self-regeneration of mangroves disturbed by tropical typhoons. So again, on the behalf of college and myself, I welcome Madam Pham. Now I request her to deliver a talk.
Thank you, Madam Jagat. Excuse me, can you all hear me well?
Yes.
First of all,
Yes.
please allow me to share the screen of the presentation. Time because the internet here is not very good. I hope you all see the slide. Good afternoon, ladies and gentlemen. First of all, I would like to thank my dear friend, Dr. Smita Chugal, for inviting me to this conference. I'm very happy that we first met in 2007 in India in an international training course in the mangrove biodiversity. And till today, Dr. Chugal is still working on the nutrients from sediment and waters in our blooming area of mangroves in Maharashtra after the cyclone Fayan hit India. And this is the reason why I decided to present my talk today on the variation of the sediment in our mangrove in Kenya. I am also thankful to the conference organization as well as the head of the Rajashi Chhatrapati Shahu College for giving me a chance to be here to share with you some results of our long-term monitoring of the self-regeneration of the mangrove attacked by a tropical typhoon. This is a big project with the attendance of many research groups, and my presentation today will focus only on the temporal variation of the sedimentary nutritional status in the self-regenerated mangrove in Kenya. First of all, please let me introduce a bit about the mangroves in Vietnam. The total area of mangrove in my country is circa 200,000 hectares. We have some especially large mangroves like Cần Giờ in Ho Chi Minh City, Lú Chá mangrove in Thừa Thiên Huế province, Tam Giang mangrove in Quảng Nam province, and Cà Mau province. Of these mangroves, the most well-known mangrove in Vietnam is the Cần Giờ mangrove biosphere reserve in Ho Chi Minh City, and its area is circa 37,000 hectares. And the Cần Giờ mangrove biosphere reserve, its geography coordinate is presented in the slide, located in an estuary formed by Saigon and the Nile River. The mean annual temperature is 25.8 Celsius degree, and the minimum and the maximum temperature is respectively 18.8 and 35 Celsius degree, as mentioned in the slide. Its mean annual precipitation varies between 1,300 and 1,400 millimeters per year. Most of the precipitation happens in the rainy season, which lasts from May to October. Kenya is characterized by the semi-diurnal tidal regime. The tidal amplitude ranges from circa 2 meters at midtime to circa 4 meters at springtime. The reserve is affected by wastewater from Ho Chi Minh City via Long Tàu and Soi Rap River. As you have probably known, our mangroves were seriously destroyed during the war by the spraying of herbicides and other chemical reagents. So the mangrove was replanted in 1978. And the propagules used for this replantation were transported to Kenya from the mangroves in Kamau province. And at that time, we planted Rhizophora apiculata due to its high economic benefits. Kenya mangrove today is the pride of all citizens in Ho Chi Minh City, not only because it was recognized as a mangrove biosphere reserve in 2000, but also because of the ecological functions and services the mangroves offers. However, the mangrove hasn't been thinned out for several years, and hence its growth is really limited. The trees were more than 30 years old, and as a result, the mangrove has become weak and more sensitive to the impacts of environmental and climate changes. Although the mangroves are believed to be a green rampart which protect the coastal populations from the calamities from the oceans, they also have to face the threats from those disasters. In December 2006, a tropical typhoon named Julian attacked the south of Vietnam, especially Ho Chi Minh City, and uprooted more than 6 hectares of mangrove in the Kenya Mangrove Biosphere Reserve. The disturbed mangrove located in the Block E10, which belonged to the 17th compartment of the Mangrove Biosphere Reserve. The tree height at the time of disturbance was 18 to 20 meters. As mentioned previously, the mangroves in Kenya was replanted afterward with the desire to quickly create the green cover. Therefore, the biodiversity is really low with only one species, one dominant species, Rhizophora apiculata, and hence we had almost no chance to understand the ecosystem dynamics. Therefore, although none of us expect for such a serious disturbance, but we have to admit that the storm actually caused a great chance to learn about the natural succession of the mangrove, as well as the changes in its functions, if any, along the succession. That's why we took this chance to build a long-term monitoring program on the succession of the mangrove after the disturbance. Actually, it's not really easy to build the monitoring program at the beginning. The administrators of the city were much worried about the appearance of pandemics, which might be caused by the insects in the disturbed area. As you can see in the slide, this is the uprooted area and its surrounding intact mangrove. The typhoon caused a drastic decline in the mangrove area, as you can see here, and this actually was the most unwanted fact. Consequently, the administrators wanted to clear the area and prepare another replantation. This picture shows that one-third of the disturbed area was cleared. The trunks and the big branches were carried away, and only the twigs were left. We, the scientists, had to work hard to convince the administrators about the importance of such research on the self-recovery of the mangrove, so that they allowed us to keep the rest area untouched. And this is the untouched zone. As you can see in this picture, in this untouched section, we had a very thick cover made of electrodes.
Hello, excuse me, madam. Madam, excuse me, slides are not moving.
Really?
Slides are not moving.
Which slides are you seeing?
Just you, we have, the screen is visible only with one slide, first slides, title slides.
I think I have. Only the first slide?
Yeah, first slide we have visible.
Unbelievable. I think I have to change the computer here. I don't know. The internet is not really well recently. Moment, please. Why do we always have the same problem with the Zoom? I have to sign from another computer.
Okay.
Sorry for this inconvenience. I need to see
okay,
the pass.
It's all right.
840 312. Please allow me to join the computer, to join the conference.
Madam, you can share again, close this program.
Yes.
Recording in progress.
Excuse me, have you seen the
Yes,
slide?
yes. It's visible, madam. You can continue.
From which slide should I continue?
So the first slide is now, which is on your screen.
A moment, please. I need to ask my assistant for help. John.
Yes, it's now move. Yes, yes. Madam, you can continue now.
Yes. So you
Thank
can
you,
see
madam.
the map of Vietnam.
Okay.
Okay. So you have already seen this slide. I think the internet in my office is not very good and it slows down the rate of the slide change. Sao thằng nó lại đứng rồi?
No, no, now we are able to see the screen.
Yeah, I clicked the button for several times, but the slide doesn't move. Nó lại đứng rồi.
Madam,
yes,
you can exit the full screen and just read mode you can accept.
Now it's working.
No, do it again, please. Làm lại coi. Nó không có chạy mà.
Chạy gì? Chạy hiệu ứng hả?
No, không có hiệu ứng gì hết, chỉ chạy tới thôi. Ngồi đó đi. Okay, my assistant will sit here and help me with the computer. So you have already seen the geography coordinates of the macrophytosphere reserve, right? So should we keep moving to the next slide? Next, please. Okay. The macrophytosphere reserve is characterized by the semi-diurnal tidal regime. Tidal amplitude ranges from circa 2 meter at midtime to circa 4 meter at springtime. The reserve is affected by the wastewater from Ho Chi Minh City via Long Tau and Srai Rap River. You can see, show the city, please. The zone with the colorful zone in the map show the position of Ho Chi Minh City relative to the Kandia macrophytosphere reserve. So to let you visualize about the connection between the Ho Chi Minh City and Kandia macrophytosphere reserve. Next, please. As mentioned above, the mangrove was seriously destroyed during the war by the spraying of herbicides and other chemical reagents. So in 1978, the propagules from Cà province were transported to Ho Chi Minh City for the replantation of this mangrove. And we planted only Rhizophora apiculata at that time due to the high economic benefits of this species. And as you can see in the picture now, Cần Giờ today is the pride of all Ho Chi Minh City citizens, not only because it was recognized as the mangrove biosphere reserve in 2000, but also because of the ecological functions and the services the mangrove offers. However, the mangrove hasn't been cleaned out for several years, and hence its growth is really limited. The trees were more than 30 years old, and as a result, the mangrove has become weak and more sensitive to the impacts of environmental and climate change. Other the mangroves are believed to be a green rampart, which protects the coastal populations from the calamities from the oceans. They also have to face the threats from those disasters. And these pictures show you the disturbance caused by a tropical typhoon named Dorian in 2006, actually in December. It attacked the south of Vietnam, including Ho Chi Minh City, and uprooted more than 6 hectares of mangrove in the Mangrove Biosphere Reserve in Cần Giờ. The disturbed mangrove here, the brown pieces here, show the disturbed area. It locates in the plot E10, which belonged to the 17th compartment in the Biosphere Reserve. And the tree height at the time of disturbance was 18 to 20 meters. As mentioned previously, the mangrove, because it is a replanted mangrove, a monoculture, the biodiversity was really low. Because after war, we planted this mangrove with the desire to quickly create the green cover. So we had no chance to understand how the ecosystem functioned, how it worked to offer the ecosystem services. And actually, nobody expected for such a bad disturbance, but the typhoon caused a great chance for us scientists to learn about the natural succession of the mangrove, as well as the changes in its functions, if any, along the succession. That's why we took this chance to build a long-term monitoring program on the succession of the mangrove after the disturbance. Actually, it was not easy to build a monitoring program at the beginning. The administrators of the city were much worried about the occurrence of pandemics, which might be caused by the insects in the disturbed area. The green piece is the surrounding intact mangrove, and the ground, as you can see, the remaining of the dead trunks on the floor. And the most unwanted fact is that the big area of the mangrove was destroyed. So the administrators of the city want to clear the area for a new replantation. You can see circle 1/3 in the picture, circle 1/3 of the disturbed area. The trunks and the big branches were removed, carried away to prepare for the replantation. But we, the scientists, had to work hard to convince the administrators about the importance of the research on the self-recovery of the mangrove, so that they allowed us to keep the rest area untouched. And this is the picture of the untouched area. As you can see in this picture, in this untouched section, we had a very thick cover made of the dead trunks. We even couldn't touch the sediment floor, but walking on the dead trunks. Next. Here is the scientific basis for the building of the monitoring program. After the visit of the typhoon, a giant mass of organic matter, inclusive of all kinds of leaves, fresh leaves, yellow leaves, brown leaves, all of them. And the big branches, the twigs, and the trunks were poured to the sediment floor. A part of these organic matters might be washed to the tidal creeks and subsequently exported to the adjacent river, the Ha Hanh River, while the others can be buried at the deep sediment layers by the crabs and other animals living in the floor. The uprooted trees made the floor be exposed to the solar radiation and led to changes in the physical chemical properties of the sediment floor. The drastic decrease in the number of the living trees might result in the less usage of nutrients bank in the forest floor. And last but not least, most of the organic matter input to the floor were woody materials, including trunks, big branches, as you can see. These organic matters are highly resistant to the decomposition and require a very long time to be fully decomposed. All these facts lead us to the loop between the changes in the sedimentary nutritional status and the shift in the biological community. And finally, it causes changes in the ecosystem functions. The differences between the three zones, as mentioned previously, vertically can be seen in the vegetation structure, in the layer for production, in the epifauna and infauna structure, and of course, in the nutritional status in the sediment floor as well. In addition, the changes in the decomposition rate of organic matter could result in the changes in the exchange rate between the mangrove and its adjacent river. These differences will vary along the succession of the mangrove after the disturbance. Well understand these processes may contribute to the determination of the ecological results during the natural succession of the mangrove ecosystem after the disturbance. Excuse me? Such knowledge is a firm basis and an effective tool in protecting and developing the mangrove ecosystem in the context of the climate change. In the frame of the monitoring program, we observe the special temporal variations of the vegetation and other biological community structure, the sediment nutritional status, and the merit change between the mangrove and its adjacent river as well. However, within this presentation, I will talk about the sediments nutrients only. Okay. This is how we arrange the plot for our experiment. We, the biogeochemists, worked in the untouched section and its surrounding intact mangrove only, as you can see. The red plot represent the samples collected from the disturbed area, and the yellow plot are from the surrounding intact mangrove. 3 transects cut through the exterior intact mangrove, which is closer to Hà Thanh River, shown in the Hà Thanh River, and the collapsed mangrove to reach the interior mangrove. 5 plots with a side 20 meters of each edge were placed in each transect and coded as shown here from 1 to 5. Next, please. In each plot, sediment cores with the length 50 centimeters were taken repeatedly in each plot by piston core during the eps. Physical chemical properties, including temperature, pH, were measured immediately by inserting electrodes into the sediment core through inlets on the wall of the core. And according to a previous study in Ganja mangrove biosphere reserve conducted by my friend Dr. Julian Oxman in 2010, the sedimentary nutrient levels at the depth from 0 to 15 centimeters and from 30 to 35 centimeters tightly correlated with the nutrient concentrations in the leaves. And consequently, the subsamples at these depths were stored at 4 Celsius degrees during the transportation to the laboratory for further analysis. In the lab, the fresh sediment was suspended in the still water during 12 hours at the room temperature. The conductivity and the temperature of the suspension were measured afterwards, and sediment salinity was calculated according to Ensminger 1996. Large amounts of the fresh sediments were used for the determination of humidity. The fresh sediments were then dried for the humidity determination, and the dry sediment was subsequently used to homogenize over the sieve with the mesh size is up 250 micrometer to get the fine powder, which are ready for the chemical analysis. For the quantification of the total nitrogen, for the total quantification of total nitrogen and organic carbon, the dry and homogenized sediment was weighed into tin cup and grabbed Silver cups were used for organic carbon analysis because we had to remove the carbonate calcium. And organic carbon and total nitrogen were quantified with the elemental analyzer Fissions and A. But since 2012, we didn't analyze the nitrogen, total nitrogen level, but the contents of ammonium instead. Prior to the determination, the extractable ammonium in the dry and homogenized sediments were extracted by 2 more potassium chloride, according to Kinney and Nelson, and shaken for 30 minutes at the room temperature. The suspension was subsequently filtered to remove the sediment particles, and concentration of ammonium in the supernatants were determined according to the Berthelot reaction. Here are some results we get during the monitoring since 2007. The first sampling was performed in March 2007 in the dry season. So you can see here the dark green, the darker blue represent the section 1. I mean the the disturbed, while the section 2 represent the intact mangrove. But from now on, for my talk, I will use the section D for the section 1 and the section I for the section 2. The section I represent the intact mangrove and the section D represent the disturbed mangrove. We have to admit that the cover formed by the dead trunks and the branches function very well in protecting the surface sediments in the section 1 or the section D from the solar radiant heat. We expect a very big difference between 2 sections, at least at the beginning of the monitoring, because in the section D, there was no vegetation, no cover. But although the sediment temperature values were always higher in the disturbed area, there was no significant difference in the temperature between 2 sections in the period 2007 to 2008. A similar result was recorded with the water contents in the sediment. In short, we can say no significant difference were recorded in the physical chemical properties of the sediments between 2 zones at the beginning of the monitoring. In the first stage of the monitoring from 2007 to 2008, the levels of organic carbon in the study area were much higher than other mangroves in the south of Vietnam. As mentioned here. We compare our results with the study of Yanayan in the East Brazil, with Trần Ngọc Diễm My in another part of the Cần Giờ district, in another study area in the lower Mekong Delta in Bạc Liêu province and Cà Mau province. And what we can see is the organic carbon levels in the study area in this study were much higher than other mangroves in the south of Vietnam as well as East Brazil. Why the total nitrogen deficiency was increases? This is because of very high tannin content in reservoir trunks and branches were the main cause of the serious deficiency of the nitrogen in the sediment. Tannin inhibited the nitrogen mineralization and resulted in the deficiency of nitrogen, but very high level of organic carbon in the sediment. And this picture shows you the presence and the work of the shipworm Teredo navalis. This is an important factor which might lead to the changes in the level of organic carbon and total nitrogen during the decomposition of the dead trunks. Under the plot in the surrounding intact mangrove were used as a blanks to compare the changes in sediment properties under disturbed and non-disturbed conditions. The acquired data show that the organic carbon levels in two sections vary in a similar range, as you can see here. The transportation of organic matter and other materials between two sections probably erased the significant differences in the elemental composition and nutrient concentrations between two sections. In the rainy season, in the first rainy season in the monitoring chain in 2007, the organic carbon level in the section in the intact mangrove were lower than the disturbed mangrove, but these differences were not significant, while the reverse trends were seen in the total nitrogen levels. Other lignin-rich materials like the woody trunks could be transported from the disturbed section to the intact section by tides. It was obvious that the impacts of tunneling on the elemental composition was stronger in the disturbed section. On the contrary, in the dry season, you can see from the pink columns. In 2008, the total nitrogen level in the intact section was lower than the other. The input of the leader form in the intact section, which were totally disappear in the disturbed section, was maintained by the living plants. And this is the reason why the remaining micromass was almost the unique source of the organic matter in the disturbed section. The fresh organic matter via the leader form in the section I or in the intact mangrove was indicated by the slight increase of CN ratio in the dry season. In 2008, so sorry, I have just recovered from the pandemic, so my throat doesn't function well as it was before. The sediment, now we talk a bit about the temporal variation. The sediment temperature in the disturbed section in the left column decreased continuously from 2007 to the 2013. Why the column doesn't appear here? Due to the increase in the water retaining caused by the lignin-rich materials in the section, in the disturbed section. Something's wrong with the graphs. No. Where are the columns from 2010 to 2012? Okay, sorry. Another problem again. I don't like this computer and this internet. As you can see, along the succession of the mangrove, the temperature, no, where's the temperature? The temperature show an increase in the 2014 in both areas, and it's more significant in the intact mangrove. Why in the uprooted mangrove? It was not really higher than the first phase of the monitoring. And I talked about the importance of the cover of the dead trunk previously. And the cover of the dead trunk here again prove its importance, prove the role of the lignin-rich materials in maintaining the water content, the humidity of the soil, because in the uprooted mangrove, in the uprooted mangrove, the soil, during the first phase, the soil humidity was almost unchanged. But in 2014, the soil water content quickly decreased compared to the first phase. This is because the total decomposition, the dead trunk was fully decomposed in 2013, as you can see here. In 2012, even 4 years after the disturbance, we can still see the dead trunks from the Google Earth. But in 2014, another 4 years later, all of the dead trunks disappeared. And you see this picture This picture was taken in field. You can see most of the trunks were fully decomposed thanks to the activities of the Pteridonavales, and it's similar. And the decomposition of the dead trunks led to the drastic decrease of the organic carbon level in the sediment in 2014 and 2016 in two areas, in the surrounding intact area as well as the uprooted area. And from 2014, we analyzed the ammonium. Here, I would like to say a bit about the reason why we didn't analyze ammonium before. In 2008 and 2007, at the beginning of the monitoring, the ammonium, we tried to analyze, to quantify the ammonium content in the sediment, but it was impossible. We couldn't find ammonium in the sediment by the Berthelot reaction. That's why we just have the ammonium data since 2014. And in 2014, and there was almost no difference in the variation from 2014 to 2016 between the two zones in the intact area and the uprooted area. But we have a strong increase, drastic increase in ammonium in 2016, and this is due to the return of the leader. We have the more continuous flow of the leader due to the regeneration of the mangrove plant in both areas, in both zones. And finally, we will go to the conclusions. We can see the disturbance caused by the Julian typhoon resulted in a significant increase. Chỗ này nằm đây sao? Phải tắt cái này đi không? Significant increase in the carbon input to the sediment via trunks and big branches. And these recalcitrant organic matter led to the critical deficiency of nitrogen in the sediment right after the disturbance. And the disturbance led to the changes in the sediment division, not only in the uprooted area, but also in the surrounding intact mangrove. The dead trunk cover really kept the sediment floor from turning into severe condition at the initial stage of the self-regeneration process. And due to the return, the initial of the regeneration of the plants, we have the nutrient concentrations in the sediment floor started to increase strongly in 2016. And that's not finished, because this is as mentioned at initial, this is a long-term monitoring program, and all of what I have said is still observed in the area. But we are thinking about other fields of the research. For instance, we started to do some study about the shift between the carbon sink and sours of the mangrove. And another field, another interesting field of the biogeochemist is the function of this mangrove to its adjacent river. I would like to tell a little story about this because at the initial phase, this mangrove acted as a significant source of phosphorus and ammonium to the Ha Thanh River. And that's why we have a very high yield of oysters cultured in Ha Thanh River. They also were very big, very fat. But since 2010, 2012, due to the fully decomposition of the organic matter, the dead trunks, the yield of the oyster quickly decreased. And since then, we are still looking for the budget, or actually looking for the collaborated to keep study on the changes, the variation of the function of this mangrove to the adjacent river. I will be very happy if after this conference we can build further collaboration. If any of you are very open to any of your research ideas for the further collaboration and to let you visualize the future ideas, please let me introduce a bit about my research center for the greenhouse gas and climate change. I would like to apologize for the changes of the topic today. First of all, I would like to talk about the emissions from the petty field, but it's a project collaborated with the JECLOB, Academy of Science of JEC, and the partner didn't allow me to publish that data in the conference. So I have to ask for the permission to change the topic from my friend, Dr. Jugala. But I would like to talk a bit about my research center so that any of you, if you have interest, we can think about the collaboration. Our research center was built on March the 8th in 2019. Our center belongs to the University of Science, the National University of Ho Chi Minh City. And 2 months later, we celebrate the birth, let's say the birth of the greenhouse gas monitoring station in the Lang Shen Wetland Reserve in Long An Province, a province in the lower Mekong Delta. A rice barn for Vietnam, and also for the world. We have a very big advantage because we had the great support from the National University of Ho Chi Minh City and the JECLOB, as you can see in the picture. The man here, Professor Mikhail Marek, is the director of the JECLOB, and he supports us very highly in every field. Actually, all of the sensors and the instruments from the Lang Shen Wetland Station were offered by the JECLOB, as you can see here. This is a picture of the greenhouse gas monitoring station in Lang Shen. This is the first fruit of our collaboration between our research center and JECLOB. And within the frame of this collaboration, we use the epicovariance technique for monitoring the net exchange between the petty field and the atmosphere. And that's not everything. We also monitor the changes in the soil conditions, namely the water level in the field, the soil water content, and soil temperature. And I am now the principal investigator of a study on the coupling between the carbon balance and the crop yield and the influence of the tillage activities in the collaboration of the JECLOB, as mentioned above. We are writing a paper about some interesting findings. We found that the petty field actually acts as a carbon sink during the most of the crop, except the first 11 days due to the starch hydrolyzation for the germination, and the last 5 days of the crop before the harvest, when most of the biomass dead and the grain respiration contributes to the emission of carbon dioxide. And we will not stop at the petty field. In the near future, when the pandemic is totally stamped out in Vietnam, we will build another monitoring station in an urban of Ho Chi Minh City, actually in Thủ Đức Street, where another campus of my university locates. We are going to be also a network of sampling stations to assess the greenhouse gas emission from the grids in Ho Chi Minh City. And we are open to any of your comments on the research ideas and look forward to cooperate with you guys in the near future. I will finish my presentation here, and I'm very grateful to any of your comments on any of your questions. And because of the low quality of the internet here, could you please type your questions in the chat box? Thank you.
Madam, please unmute yourself.
Now, can you hear me?
Yes, madam.
Audience, delegates, participant, if you have any questions, you can ask. I welcome you. One or two questions only.
Please type your questions in the chat box because I couldn't hear you very well here.
Okay. So delegates, you can paste your questions in message box also. Later on, she will give the answers.
The signal is low here, so sorry for the inconvenience.
Can you conclude now?
Yes, madam.
Okay. So first of all, I congratulate Dr. Sam madam for giving a very well talk on the topic of changes in sediment nutritional status along the self-regeneration of mangrove disturbed by the typhoons. Madam, our department and university both are actively engaged in mangroves research. So, I'm proudly telling you, too much work was done by the department in India on mangrove. My senior colleague, Professor L.J. Bhosle and Dr. Niranjana Chavan, madam. So, madam has focused the role of mangrove and their importance, as well as how the climates are responsible to change the sediment nutritional status along the self-regeneration of mangroves. So, mangroves are a very important part of the planet, and mangroves are amongst the most productive marine ecosystem on Earth, providing a unique habitat opportunity for many species and key goods and services for human beings. So, mangrove habitat are regressing at an alarming rate due to the direct anthropogenic impact and global change. Mangrove plants are mostly the trees and large shrubs, but also include ferns and palm species. So, according to the 2010 World Atlas of Mangroves, there are a total of 73 species and hybrids which are considered to be the true mangroves, those that have adapted to mangrove environment and are rarely found elsewhere. So, mangrove performs important ecological functions like nutrient cycling, hydrological regime, coastal protection, fish fauna production, etc. And mangroves act as a shock absorbers. They reduce high tides and waves and help prevent the soil erosion. And everyone knows that how the mangrove play important role in the protection from the tsunami, because after the effect of tsunami, whole world will be going and concentrate on the mangrove conservation. So regarding this, the today's talk are very important and excellent. So on the behalf of myself and behalf of the college authority, I am very much thankful to Dr. Sam Madam for delivering an excellent talk. And everyone are beneficial from this lecture or from this talk which was delivered by Dr. Sam Madam. So once again, Madam, lastly you are speaking on the collaboration. So I ensure that the college authority and university authorities both are in future wishing to collaborate with your institute and make in future MOU in between the two institutes, your institute as well as Shivaji University. So with this, now once again I am thankful to the college authority, Dr. Sam Madam, for giving me an opportunity to work as the chairman of today's talk. Thank you one and all, and now over to the anchor.
Thank you, Dr. Sam Madam and Jadhu Madam. Now, I invite Mr. S.M. Gozare Sir, Assistant Professor from Department of Botany, to give vote of thanks.
I conclude the third talk of first session by expressing vote of thanks. First, I thank the resource person of third talk, Dr. Pham Yang, Coordinator, Research Center for Greenhouse Gas and Climate Change, National University, Ho Chi Minh City, Vietnam. She shared her view very well on the topic temporal variation of sedimentary nutritional status in a self-regenerated mangrove disturbed by a tropical typhoon. Next, I heartily thank the chairperson of this session, Professor P.D. Jadhav Ma'am, Head, Department of Botany, Shivaji University, Kolhapur. Once again, thanks to resource person, chairperson, and all delegates. Thank you.
Thank you, sir. Ladies and gentlemen, let us break for a lunch. We will come back sharp by 2:30 p.m. After that, we will start with poster presentation and oral presentation.
Thank you.